Hey, guess what? I'm live.
It's amazing. What? There is no color. Bro, I forgot. Either I did the invert thing as the exclamation mark. Apparently, it's like the back tick. Oh, no, it's not the back tick. The shift back tick thing. It should work.
Hold on a second. Where's the channel?
1 second. It's at LTDSYT.
Because is it a new one? Because I'm not subscribed anymore to the one I thought was the one.
You are. It's LTDS. I just changed it. I just shortened its name.
Oh, also it's down more into my list. Wait, no, what?
My subscriber count hasn't gone down, so you're still subscribed.
Can you send me the thingy?
It is an announcement.
Oh,
Oh,
yes.
nice.
Yeah, I'm subscribed. What's... Oh, because you're at the top. You're live. Okay, okay. Right. Sadly, I have a lesson that I have to. So I just stay here, muted.
Seems like it worked. Nice.
Da, 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 da. I feel like the first like 10 minutes of every stream I've ever done in my life is always just me fucking around and trying to get things set up and get going. Like even when I streamed Satisfactory stuff every single day for like I just had realized I did forgot to turn off push to talk in Discord. But even when I used to stream Satisfactory stuff like every single day for like a year, year and a half, I would still spend the first 10 minutes setting up on stream. I would never set up beforehand.
Alright, I'm back. Just use the bathroom. What should I work on next? No
Oh
and
no,
overflow. I should continue my ISA
that works.
because I finished coding everything. So
But just letting you know, your voice is on the YouTube.
now,
Yeah, that's why we're in
all
this
right.
channel. So whatever you say can be heard by the world.
I think this is the first time I've been on a live stream.
So yeah, the Runahead Queue. I should really fucking amazing game. Sons of the Forest is like god tier game. Story's a little short. A little short for my liking, at least. Still fucking amazing. I just wish I had more hours to play it. But yeah, so in this block diagram, I'm currently working on the Runahead Queue, and I'll stream in Discord as well, so anyone in there doesn't have to like worry about YouTube delay. So in this block diagram, we have a lot of stuff worked out. I was just kind of like throwing these things down last time. The Runahead Queue is matched here only because it's going to be buffered. With the output, it's going to just come through, be buffered, and then this is going to be like a three-way mux. That's going to mainly prioritize this. Actually, to show that more accurately, I should really. I should just really make this like long. Fuck it. I'm just gonna make this really long. Boom. The fuck? I don't want to do that. Sometimes this thing moves lines in the weirdest ways that I just don't make sense. There you go. That makes more sense directly of what it's gonna happen. So okay, there you go. So because what the order of operations would be like to prioritize the instructions you can possibly. Hi, Blessing. How are you doing? I just saw your chat. Sorry if I was late. I'm guessing you're for more. Thank you for joining. Since this is a run ahead system and any instructions that you can't execute because they had dirty operands here go into the run ahead queue. In order to maintain that you're actually progressing in the program, you need to always make sure you execute the oldest available instruction first. So to do that, since this is a queue, the oldest instruction will be at the head of it anyway. So at this junction, you check, is there an instruction ready to be executed at the front of this queue? If not, then choose this primary path. Choose this primary path. If there is, then execute this instruction. The next decision would be if there's not instruction ready there, then is there an instruction in the stalled buffer? Wait. I don't. Actually, no, okay. I was just wondering if I wanted this to be ahead or behind branch prediction, because the idea is that a branch would come in here and it'd be like, oh, cool, I'm gonna execute a branch. It speculates on the branch and it pushes it and it goes, well, that branch doesn't have its result yet. So then it comes up here and gets put and it goes, cool, I'm gonna wait for that branch to be done, and you can only speculate one deep. So if it gets another branch, it goes, well, shit out of luck and jolly well fuck, gonna wait. And the run ahead just keeps going and processing its instructions, letting stuff finish until the run ahead sees that its operand is valid and goes, gotcha, boo, and processes. Sup, Optimo? Hello, Dennis. I see that you moved to Discord. But yeah. So, and the conditions of instructions going in there are what I'm covering here. This is going to be, every register is going to have this little tiny state with it. It's going to be a standard vector, but this is going to be a vector of 3 bits, and I just pulled those 3 bits off on its own little thing. Mainly just to read it easier, just so that way it's easier to understand what's happening. So the conditions would be, first, do you check if you want to put it to the run ahead queue, and if you can't, then do you stall, or if not, then you actually issue it if you don't stall and you don't do that. So yeah, making these, we go to this dirty. So if you're dirty, or if you have something that's to be read, then that can be executed. So that doesn't matter. But if you have, so you only get sent to there if you using a dirty operand. B operand. Mark to be read, regardless. doesn't really matter. And then when to stall. A dirty or B dirty. So if A is not dirty, because if A is to be written, then you could be the instruction that's writing to it. So that's fine. B operand. Yeah, it's not dirty. Okay. Else issue. You stall. Not a dirty. Okay, I've looked at dirty so many times, I don't even feel like it's spelt right anymore. And is it? Okay, it is. I've seen the word so many times now, it just doesn't feel right. Okay. Let me stay with my note conventions. When to issue from Runahead. So if it's not dirty, A operand. Do nothing. Do nothing. Clearing the 2B red flag is going to be the hardest thing, and that may end up becoming a complication. That's the biggest complication I foresee. When to stall would be okay, so that sounds easy enough. I don't even change the operands at all because it's a stall. Okay, when to unstall. This is also a do nothing, do nothing. Yeah, A operator, when to So if either operand is dirty, we're gonna push it to the Runahead queue, and then you mark A. If A is dirty, you mark it to be written. If it's B, mark it dirty. Oh, fuck yeah, I know what we can do. Sweet. To be read. Needs to be a counter. Needs to be a counter. Yes, it do. Hold on, why did I have the to be read flag? I'm trying to remember. If you issue an instruction and you check it, you have to mark that to be read. Oh yeah, because if anything writes or A to be read. Okay, cool. Sweet. So then if A would be if dirty or so if this is a question. So if I'm putting it to the run ahead and it goes to A to be dirty, A to be read, that means I'm waiting. I'm going to push it to the run ahead queue to write, which would mark that registered dirty. Yes. Okay. Or does it? Nope. I'm going to put, I need to be able to track this state differently. I don't want it to be there. So I'm going to put, if you're dirty or if A is to be read, then you mark A to be written when to issue from run ahead and A to so if A was dirty and it was marked to be read, yeah, so that way you mark it to be read and you mark B to be read. So that way any next operations that want to write to that end up wanting to write to A will go, oh shit, I need to write that to be written. I'm actually just gonna make that its own separate case. If A to be read I put this here just because it could be not dirty and it could be this. So if it's not dirty, it needs to be marked dirty. So if you're not dirty and you use and your A, but your A is to be read, then you would have to mark it dirty and to be written. So that way any instruction that would want to go after that. Could I track a single dirty? No, I can't. I don't want to. That would be nasty. Just thinking. And no one in Discord's saying anything. They're all being all quiet. They're all muted.
I got no idea, man.
When to clear dirty. It's parentheses and slash because the load port here covers anything from the complex queue, from any complex multi-cycle ALU operation and any loads. So it's kind of a hybrid-y thing. CSRs may also end up, depending on how long they take, they may end up coming down here too. I don't know. I'll make this just like a dot, like a super dotted line, because I'm not sure where. I'm still debating where those need to go. Depends on how many cycles the CSRs end up taking.
Are you finished with this block diagram?
No, it's I'm like I'll just say 80% because it's still just like shifting around as I'm going. Like I'm refining it, adding more stuff, and like shifting things around. You know, I just realized I could make this a lot cleaner by just pulling this out a little bit.
Looks good.
There we go. Now it looks more even. Okay, so
I I just didn't want to interrupt your stream, but it's
you're funny. You're like I'm in here in voice chat just so if you have questions or you want to talk, you can. I'm gonna get up and stretch here in just a second though, because I want to heat up some tea. I just realized my mug of tea is empty.
no.
I just realized I had my Discord. I was wondering why I could barely hear anybody, and I realized my Discord volume was still set really low from when I was in Teams yesterday, because Teams volume is so loud. I haven't just fixed it yet.
They started to charge Teams free. I don't know. Microsoft is running out of money. What are you even programming? I don't get it.
I'm making a microprocessor.
Yeah, I got that. I guess I got that far.
The Runahead Queue will let you stall out for one operation, right? And then boot up. This lets you do avoid a write after write.
Yeah, I'm realizing that I just need to always mark this to be written and to be read. Yeah, so normally in the CPU, and I'll pull out Milton. Okay, so normally you have like a CPU, and you just run instructions. It's just a normal CPU, and then you go up to like a pipeline CPU, where you have like
Oh yeah, I know.
yeah, you have like pipelines 1, 2. And then you have your instructions issue like A, B, C, D in order. What I had in here before was you had an array of bits per register. And this bit was a dirty vector. So you had your value and you had your dirty vector. And if a bit whenever you would if you'd use a value for something that's like the program counter, like a jump or one of these ALUs, like anything that goes through this mux here, like this single cycle mux, then it would do nothing. It would just act as normal because the forwarding will catch all those cases and you're fine. It just continues like a standard pipeline CPU with forwarding. But if a dirty bit is set to 1, then the CPU will stall until this dirty bit goes to 0. You set the dirty bit 1 when any operation requires going out here into the multi-cycle area. If you end up having to do anything multi-cycle, which could be the CSRs later, the old CPU didn't have them, so that's still up in the air. Complex things like multiply or like system reset stuff.
Yeah, I know.
Any loads and stores, any of that type of stuff comes in and it marks it dirty. So that way, if you do a load and store, you can do a load on like line 7. Like if you had your code right here and you had up all these lines, you could do like a load here, R4, then hex 72 or something like that, and you load that in, and then you could do other stuff here. You could do other stuff on each of these lines, and then you could finally have like an add R4, R5. And what this would do is, if this load wasn't like L1, let's say you have like a cache structure, and your cache took like two cycles to respond. So instead of it'd write to the it'd write in like right here or something like that. Like it had a delay of a slot, and there's no forwarding on that line, so it'd have to be right. It writes here on this cycle. That would allow you to do a load and do these 3 lines of code and not care that the load hasn't come back yet and the CPU doesn't stall at all, because it just says, oh, that instruction is dirty, so it just lets this continue, and it properly stalls the system if the load isn't back.
So it's kind of like threaded processing.
It's more like scoreboarding, where you mark like registers that have instructions currently out in flight. I'm only doing it on I'm doing on anything that takes more than 1 cycle, because standard forwarding covers for that. So anything that is multi-cycle, so I don't know how long those operations could be. So let's say I add some division later in the ISA, and I don't want to have to reprogram like assemblers or compilers ever to deal with that difference, to deal with those different cycles and stuff and accommodate for them and prefetch and things like this. This allows you to write prefetch code where you just, as soon as you know the address of a load, you can load it into a register and then use it later. And even if you use it too early, like if you use it on this line, if this was the add, then this would just stall the CPU for 2 cycles and say, okay, you're good here.
But it would just wait, right?
Yeah, so this tells the system, hey, wait, I'm not ready for you. It just gives a really arbitrary and basic mechanism to give somewhat out of order.
So the dirty mechanism is like, if the dirty is still 1, it will wait till it gets to 0.
Yep. So it becomes really nice when you just want to do a load from memory and you want to make sure that your CPU does the right instructions, but you don't know how long it's going to take. This will just let you do that load in, do a bunch of work. You could, like, if you knew you're going to do a loop like 50 times or something, then you knew it was going to take you like a few hundred cycles to do something. You could do your load before that loop, and then when you get out of that loop, even if it was an L1 miss and had to go to L2, it should be there. If it went out of L2, maybe it's not back yet, but you increase the chances of not having to stall because you can preload pre-do your loads.
So it's kind of like threading or like async. Yeah.
It's kinda. It's like it allows it to be super scalar and not care that things take different orders. Because like if you just do a standard super scalar and you would just have all these different units and you'd say, hey, I want to issue a load and an ALU operation at the same time. And let's say you know that all loads in this particular system, you have a small chunk of memory, so they all take like 4 cycles. So you do a load, and they always write back on this same cycle. But if these two are writing back at the same time, if let's say this was writing to like R7 instead, you'd have to have a register file that can support dual write. If you didn't have dual write, in this case, you'd have to stall this out.
Yeah. Okay, I kind of got it.
So the workaround that I still have dual write because I want to be able to write both these at the same time. But the way that systems would get around not having to have a dual write is they would either just add the dual write, or they would put where this add is, they put a NOP there, so that the way they would know that the register file would only ever have one write operation, because the NOP would be programmed in the CPU to not write to the registers, so you would never have any collisions. But for my system, because the collisions only really are an issue if these addresses match, because then you know, oh, what should I handle? But since this system marks things dirty, you know that if there's 2 writes at the same time, they're always going to go to 2 different registers, because you're only ever going to write to a dirty register, and the ALUs aren't going to write to a dirty register because by the nature of the system. So this bit isolates the read contention or the write contention.
And what are you now exactly programming? Because I don't know how you're like trying to like. So you're trying to program first in Python or
no? This is system Verilog, so I'm programming it to put on an FPGA and actually like use it as a real processor. So over the last summer and since the beginning of last summer, I've just doing these same like 9 to noon sessions, just in a different channel and like with a small group of people. And we pretty much went through designing the first version of the CPU, which is this diagram over here. It's more, and this has just the dirty bits. This has a register that just has the dirty bits and stuff like that. And this CPU here is fully operational and runs what I just explained. I'm upgrading that to a system with Runahead, where if you run into a situation where like a register is dirty, you just put that instruction to a queue and execute it later.
Yes.
So the mechanism that I'm coding now is the table structure that allows that handoff to actually happen. So this system these are the conditions I'm going to check, because in order to do this, instead of just having one dirty bit register, I need to have a few more states of the register in order to do this like effectively and get more optimization out of it. So yeah, does not equal 0. So then yeah,
but like shouldn't it be like a Minecraft CPU then?
What do you mean?
So what are you're programming the logic first to like replicate it then in Minecraft, or?
No, I'm just making the CPU to be a CPU to use in real life. Because I'll be using it for things for different like hobby projects and real life stuff. And one of the things that I'm working on in this Discord with a few people is making a debugger tool set that helps you like work through helps people that when they write this type of code work through like their code and how it's operating, so they can debug it a lot easier. and part of that debugger is going to be the ability to like compile your project through whatever program you have. It'll just use scripts to compile it, but it'll modify your project to allow you to like look at different portions of your system. And this CPU that I'm building is going to be the management CPU that ends up getting put on there, so that the debugger can communicate with. So this is going to be multi-purpose. It's just, it's highly dedicated to run like exactly what we need.
Oh, okay.
And
What
it's
language is it anyway?
system Verilog. I'm just commenting now. This is more
Yeah,
like
no.
like I have this is so this is a register queue, so it's a FIFO. So I have this right here, which is just a FIFO. And then it's just a head, a tail, a thing, and then I need to update this, like it says, make it buffered. So instead of checking when it's full, have a buffer that that checks for when it's going to be full next cycle if a condition happens, and then have it update when that condition happens. So, yeah. The goal, that would be the idea. Is
Never
that you
programmed this language. I never programmed this thing.
You don't use it for anything software. It's hardware. It runs differently. Every line of code is ran at the same time.
Oh.
Since you're describing circuits.
Yeah, yeah. So
Yeah, it
it's like,
describes if you want to think of it in a programming way, you
While
can
you're
think of
talking, I'm
it
gonna get up.
as a description of Boolean logic almost, but rather like digital logic, and then it describes how everything plugs into everything, and then that can get synthesized. So it might be code in the sense of that you're thinking, but it's very, very different from traditional programming.
I just started to learn a functional programming language. It sucks.
It's interesting. Lisp is very fun.
Yeah, I guess it's actually so much fun to do it, but it's like the learning curve is. I still
Yeah,
don't know how to do it.
like one of those things that you will learn quickly about programming and the fundamental nature of stuff is that kind of programming languages, at least when it comes to like normal programming, is all of it boils down to machine code and C effectively, and all of these extra things are abstractions. And sometimes, so you can get to a point where you have abstractions that are made out of abstractions, and abstractions of abstractions of abstractions. And
Yeah.
that's kind of why functional programming languages can be hard to learn, because it's just extremely abstract, and there's a very large disconnect between what's actually happening and what you're doing at a high level. That's one of the things that is very refreshing about hardware description languages, in the one sense, is that yes, you can write fairly abstract code, but the way Capo goes about programming is very much one-to-one to what's actually going on under the hood, which it's fun. It's a different way of thinking, and you'll be a better programmer for it. I would recommend sticking around.
Well, I'm just good at C++ right now, or like.
Well, Verilator is one of the best tools for simulation testing, and that uses C++ test benches, so you're halfway there.
Yeah.
Woohoo. Great. But right now I'm learning Futag.
Hey, Kappa.
What?
We should consider doing like a smaller CPU like that, just like 2 or 3 sessions where everyone codes along for newer people.
Like a code along like we did the first few sessions?
Yeah, but in this case, like a very scaled back CPU. Maybe it only has 8 instructions. It doesn't have pipelining or nothing. Like a simple as possible type model thing,
See,
like the rail thing. The
I
other guy
could
was
see you
making.
doing something like that potentially on like. I would love it if I had a third day to get dedicated, like do Monday mornings, like do a short stream, like an hour long every Monday from like 9 to 10, where I just like it's a code along session for a basic CPU. Then Wednesdays and Fridays are like developing this thing.
Yeah, because this thing is for new people
It's
is
yeah, for new
very
people
high
it's
level.
way overboard. It's just something that like
Yeah.
anyone who likes computer engineering could put this like stream on in the background or like study from
Yeah.
it in a way. But like one of the ideas of streaming this is that it's stored on YouTube, and then I can go through these things and condense them down and edit them and just use like the code portions of it to like get good content.
But yeah, like like if you already understand fundamentals, it's like an interesting thing in programming is like you first initially you're drowning in the individual semantics of the language you're working with, right? Like the specifics of the language. But eventually, when you're programming in many languages and you're very familiar with all of them, getting better at programming doesn't mean learning a new language or getting better at low level stuff in a specific language. Not just low level stuff, I mean specific stuff. It's more about architecture and high level ideas and big picture stuff at the higher levels, right? And so this is very great for this when it comes to system Verilog. But it's not so helpful for people who do not have that fundamental low level mechanical, you know, stuff. So maybe we should do a second mini series where it's like maybe a 4-day CPU or a 3-day CPU. Like really
I could do
simple.
like I could easily see doing like maybe like maybe for 2 months doing 1 hour every Monday, so 8 hours of total dev time. But then putting that into one playlist. So yeah, at first I don't have that much. I don't have much for them. But then anyone new that joins in and wants to like catch up, I can say, hey, here's a playlist. It's a total of 8 hours, but it goes through this. And as I'm programming the CPU, I'll walk you through it. Like I'll pre-design the ISA. I'll pre-design all the parts and everything like that, so that I can just go through the process of why and how I built the different. You're building the different things and what it looks like in RTL and stuff. See, my goal
like
for doing that,
simple.
I was gonna do that, but my goal was to wait until I had the debugger, so I could actually then like show the RTL and play with it and like have an intuitive sense I could teach people. And that's one thing that I'm dying, and that was the original intention of the debugger. Like my very original goal was, if I had a tool like this, I could, when I give lessons or teach people, I could show them and have a good teaching tool like to do streams and stuff with, and then they could play with it and see if they can replicate or make something similar that behaves the same.
What you could do is, because it's only 8 hours, that's not a huge time investment. Maybe it's worth doing it now with the tools we have at the moment, even though they're not the best, just so that there's something in the meantime. And then later revisiting it when the debug tool.
Say that again. Sorry, I didn't hear you.
So because the 8 hours is such a small time investment, it might be worth doing it with the tools we have now. And so that new people can, you know, get with the program. And then later just redo it when the debug toolchain is there.
Yeah, that could be it. Plus, that would also that would be a really nice way to do it actually. Cause
It would also be a really good demonstration for why the debug toolchain is better, because now you have two projects that in detail is being run through, and you're doing both, but the same thing. You're implementing the same thing, but with separate toolchains and or extended toolchain would be more accurate, you know. But yeah, so maybe like an 8-hour thing for a very, very, very simple CPU. Like literally, it can just run fib and that's it. Right?
What I think I could do for that is probably work it out where I had like 2 different Saturday streams that were 4 hours each. I don't think my girlfriend would care, because that wouldn't be a longer term commitment. But I could do like maybe like, not actually, but like next Saturday and then like the Saturday afterward, or skip a Saturday or something like that, and and say, hey, I'm gonna have these 2 and do 2 streams of 4 hours each. A, because 2 4-hour streams is more digestible. And B, like it would get the content out relatively faster, and Saturday would be an easier way where I could like promote it on OR for like a few weeks leading up to it and promote it out here and ping people so that way people could like show up and go, okay, cool, I'm here to
Yeah,
learn
I
how
would
to
love
use this
to.
Verilog.
To participate in a stream like that. Then maybe after that, you could slot in 1 hour on Mondays or something, where you go over the missing gap. So you're not touching
So like go
Verilog.
super deep into what you use logic wire and reg to on
No.
like one session.
The opposite direction. If you're doing the full 4 hour, the full 8 hours initially of let's make a CPU Verilog and all, that's very simple. Then we go in the opposite direction, because now we have the fundamentals, but we don't have the architectural elements. So we understand how to make individual components of a CPU, and the architecture of the CPU that we're going to make is very simple. It's going to be extremely simple, right? So there's something to learn there, but it's nowhere near what the pORC CPU is, right? And so you need something to bridge that gap between the architecture of pORC and the architecture of a simple as possible model computer.
Like a really
And-
simple like 3-stage like 8 instruction, just really basic pipeline with maybe just simple forwarding.
I wouldn't even put in the stages at all. I would just do one thing at a time, even though it's slow as hell.
You know what I could probably do actually?
Mm.
Start off with do a 2 4-hour session, right? I could work
Yeah.
this out. It would have to be like a couple months apart because I feel like my girlfriend would get mad if I did it like every other Saturday or something like that.
Yes.
Because Saturdays are like our time together that we always go out and do things. But if I could
Yeah,
do them like a 4-hour session, like maybe 2 different Saturdays, and then skip a few months, 2 different Saturdays and stuff like that, and each time, the first time be the most basic, like single CPU and a single module that does like nothing complicated at all, the most basic thing ever. And then the next
I'm
session,
talking like so simple, it can literally just run fib and that's it.
yeah, essentially just that. And then from there, I do
minimum
another
possible.
session where I add like memory to it, I add load and store, and then I add another session where I add like branching versus just jumping, and the different. Then each one of those
I think
CPUs
you
would
need
literally just be a new
branching.
CPU with just that added thing, and I would use the last CPU as a template.
Yeah, so you could do, yeah, but so that makes sense. Maybe it might be a little more extensive than just that, but then just like the bare minimum of a Turing complete system, right? Then one where you're just doing diagrams, so you're just going over what pipelines is, the idea of out-of-order execution, and just looking at your lucid charts. Right, and so you start with the 8-hour session CPU. That's really simple. Maybe it has 1 or 2 extensions, but the simple one. And you go from just in the flowcharts, not the actual code. You go from that pipeline to pORC, and you go one by one, add the extra blocks and bits, and explain and go there. Just so that there's some kind of a bridge, right?
Mm-hmm.
Is kind of what I'm getting at.
Yeah.
But yeah, I would love to participate in that exercise of making the as simple as possible model thingy. If you
Yeah.
wanted to,
You could make it in literally like
design-
100 lines if you only had like 4 operations. You want to make it super simple, like an 8-bit
that
CPU.
might be a bit too simple.
Well,
like,
no, it would actually. I
sure.
feel like it wouldn't be too simple because, like, when you're starting in like Minecraft, that's what you build. Like,
Yeah,
you
but
build
we're not
like the
working in
stupidest
Minecraft,
simple.
right?
It doesn't
maybe
matter,
if
but
it
like
had
that's. I
load
feel like
installed.
a lot of people when they get started, they just want to know like, okay, how do I decode an instruction? Just simply having a 4-bit decode, like a 2-bit decoder that says, okay, this is going to be a jump, an add, a subtract, or an or something like that. Like it has just those 3 operations would be really nice.
Well, making a CPU like that shouldn't take 8 hours, right?
No, like that's what I mean. Like if I start off that soon, I could literally do like an hour session where I just like do 1 hour on a Monday and I do that, and I could build it out to where I schedule the amount of time it would take for each one of these CPUs, and as I go, since they'd be getting more complex, I could more accurately schedule time. Like this first one, I'd be open between 1 and 4 hours. I'd schedule like a 1 to 4 hour stream to just go over this most basic CPU, and we could decide what instructions ahead of time were going to be in it. And then it would just be, hey, this is the instruction set. I chose these instructions for this reason. Let's get started. And then we would go through all of that. And even if no one watched it then, it would be a really great video to have up and a really great stream just to keep up as content. And at a later date, I could then go through and like have someone edit that down into like maybe a 20-minute video. And then as I make more CPUs, I could get more and more edited down where they could be walked through.
Yeah, so what you're describing is an extremely simple 400-line CPU that can barely do anything.
Yeah.
Then going up to something that simple as possible type model stuff, like maybe condition branching, no pipeline yet, but let's say old instruction store load, and it runs a fib program, right? Then you can go up to a CPU that has a pipeline and some very simple out of order execution, but a garbage implementations of those concepts, like nothing special, but just as simple as possible. Like it's technically out of order, it's technically a pipeline, right? And then you can go purely to charts and say, I've explained to you what forwarding is. We've made this the simplest possible example of forwarding, of pipelines, of out of order, of blah, blah, blah.
Yes.
And then you just take a chart and add the things until it looks like pORC. And then for sure one should be good to go. So maybe if the entire experience takes maybe 15 hours.
Yeah, even if it's like 15, 20 hours, it's still so much less than school. And even if it takes me a year or two to get the content out, getting it slowly released and stuff like that, making sure it's all good and within like 6 months or so, we should have the bare minimum of the debugger. So by the time I get to like the third or fourth iteration, we should be able to switch from just this workflow to the other, and it'll then go much faster. So as we get more complicated, we won't be like, the time won't be exploding as much. It'll actually get like a huge shrink.
Yeah. So I don't know. That is something I would consider doing.
Like I've been ever since I started this Discord, I've wanted to, like, the whole point is to release like a debugging tool set that allows you to have the workflow of this type of stuff without wanting to like pull your hair out. And then use that to make educational content on here and resources, like even if it's even like a lot of modules, like some basic CPUs. Like once I have each of these CPUs, people can then, like, if they want to have like a pre-made CPU for a project, they could just use like any of these up the list and know that they have varying scales and just have a done CPU to use as a reference. If they know, oh, I have a target of like this kind of things, and over time I could potentially get, like, since I have the Learn to Do Shit website, I can just use that, and I can have like a page that like has list all the different CPUs as they're made and compares and contrasts like pros and cons of them, like as you go down the list.
That is true.
You can have like, hey, this CPU, how does it rate on a scale of 0 to 10 of like size, 0 to 10 on speed, 0 to 10 on clock speed, those type of things, 0 to 10 on like branch penalties and different things like that, load penalties.
I have a meeting in like 20 minutes, but yeah.
That's fun.
Yeah. Yeah, dude, that sounds cool. I think that having a smaller scale thing to start with, but like it should genuinely be something that someone could program along, right?
Yeah.
And oriented around that. Yeah, otherwise it's just you sharing stuff.
Planning to make YouTube or?
Pardon?
Okay.
Yeah, I think he asked if you're planning on making YouTube, and yes, he's literally live streaming to YouTube at the moment, I think.
Yeah, I know.
Yeah, that's where he found me. I posted to Or, and then he came on.
Yeah.
Oh, okay, cool.
I know. I'm from More, so. Oh, something.
Cool.
But it's like I don't have too much of an idea in Minecraft CPUs. I just know a lot about normal CPUs. So
Yeah, it's the same thing. There's no real difference.
yeah, I kinda got that.
The only thing that's truly a difference is that Minecraft CPUs are really slow because the underlying medium that it runs on is really slow, right? So you kind of have to design better CPUs than you have to do in real life if you want to do anything meaningful with them.
You're talking about in Minecraft?
Yeah.
Yeah, that's why I love. So I'm gonna like put myself in a fucking soapbox real quick because I've been doing Redstone for now 10, 12 years, and about
Yeah.
about a year and a half into it, I started making adders. I was like, this shit's cool as fuck, and I refused to look up. I just experimented on my own for like 3-4 months, and then looked some stuff up, joined OR, and learned all this stuff, and I wanted to learn execution, like out of order execution, and all these things to make CPUs run faster, not just make faster clock speed, but actually use that clock speed better. That just really fascinated me, and I was researching it.
Optimization.
Yeah, optimize like processor architecture optimizations.
Yeah, yeah.
And no one on OR was really studying it. Like pipelining was something that was like unheard of at this point on OR, and I was like, and only like 1 or 2 people were really doing it. And I was trying to get into it, so I started researching real world stuff, and I started realizing that we were in the stage of the real world like 60s, 70s, using some techniques from like the 80s for some things, but we were like a skewed spectrum. And I realized how accurate like the type of logic that we were doing was to real world processors. Like there was a 1-to-1. The only difference is we abuse free ORs, where on FPGAs you abuse multiplexers. It's just what type of operation you get cheaper. You get additions and multiplexes really for the cheapest operation you can in on FPGAs. And in Minecraft you get ORs all day long for free, and you get diodes for free. So you can use those to your benefit to optimize the hell out of a lot of logic. It's just what you're optimizing it for. And once I realized that then I was like, hold on, if someone designs something for an FPGA, that's one thing, but if they want to hyper optimize for an FPGA, that's a different process than taking that design and making it to go into transistors and actually making a chip. And when I realized that the only difference between those is what end game you're optimizing for, I was like, hold on, Minecraft is literally just a third like branch of this tree. We're just we have a different spectrum of things we can optimize for in a different manner in our with the different like clock domain size and scaling and all that stuff. And since Minecraft is so slow and so laggy, we couldn't just we weren't able to be like the real world where they made their first CPUs and they made their second ones. They came up with ideas. They realized, oh, we won't be able to do those. So they waited for a year or two, and then transistors got smaller, and they waited for a year or so. And transistors got smaller, and they go, we can fit our ideas now. And like now they're just like, and they could just fit their ideas. You can't. There's no. Oh, we can now. There is because MCHPRS. But before that, like there was no other way to scale the speed of Minecraft just by pressing a button or like changing a technology. You had to build faster components using more optimal logic in a more condensed fashion. There was no other way to get faster. More optimal logic and more condensed. Period. That's it. There are only ways. So you have to really, really look at logic and go, well, this real world stuff, they have all these checks, but you know, you can get rid of a lot of those if you do this.
Yeah, because like there also were like new technology, like new Minecraft updates brought new redstone technologies like the target block and
comparator.
Things.
Comparator was a huge like revolution.
The comparator was huge. Oh yeah.
That's I think is the biggest like change in all of Redstone. That had the biggest impact, I think.
Because it literally allows you to do addition and subtraction without.
They're free They're like 1-bit multiplexers. 1-tick multiplexers. They're so good. So, like to finish my soapbox, I kept telling everybody this is the same stuff. If you can build this in Redstone, I guarantee you could get a job doing this stuff real world. The only problem is the way that it's going to be taught is going to be taught that you need to learn software, and then now you need to learn how you make a hardware to run that software. But you already know how to build hardware, and you're just in the way that everyone at Redstone is. They're building a CPU and then learning how to program for that CPU. That's an amazing way to learn hardware. And the whole goal of me
Right.
making this debugger is continuing that path where you can make hardware and then debug your hardware, and you're just having fun chasing that pathway, because you can learn the stuff that takes 5 years in college in like 6 months on or doing it this way if you just follow the right path. And it's a lot less confusing, because instead of you learning software and how it maps over and stuff like that, yes, that's valuable, but in my opinion, it can be, you can learn that alongside or a little bit later. But like just building the hardware and seeing what you can do and saying like, hey, I want to write fib and build a basic CPU, and going, you know, this could be a little optimal if it behaved a little bit differently, and then learning what you have to do to get that little bit more speed, and then writing a little bit more complex program for it and learning what you have to do to get that speed. And if you chase that based on what programs interest you most, you'll end up automatically specializing in GPUs or an FPGA development or an ASICs or in CPUs, because you'll follow your own chain of curiosity, learning how to optimize hardware for your use case. And it's just such a better way to learn, in my opinion. And that's the goal of all this. And I've been preaching to people, guys, you're like so far down the road of learning hardware, just fucking commit. And everyone laughs. It's like, no, it's totally different. We still need to go to college. I'm like, you literally know it already. I'm telling you. It's the same, and the more and more I learn, it's literally the fucking same. It's just time scales.
It is.
Like,
Time scales.
I guess I built my first Minecraft CPU, but it was like very shitty. It could just do 8 years ago or something like that. It was quite amazing because I could like I was like young age, so I showed my dad and could calculate. This thing could calculate. I was amazed by it. I was thinking, how amazing is that you can make in a game a calculator by your own with some logic. And right now, like years have passed, and now I'm back to Minecraft CPUs. I don't know, like I still know the basics, but like massive things have changed, like comparators, target, everything. Like Minecraft CPUs are now so much faster. Yeah, it's amazing. It's amazing.
It's so crazy. Like I love seeing how like there's
I just joined on OR because I heard about the Argon, and I'm really interested in Hex. So I just joined the OR server. Like 2 days in, I got my builder rank, and now I'm building. I'm doing on the hex layer problem stuff right now, optimizing. But I like normal code optimization because I want to like improve on it. So I'm improving right now the calculation for the hex layer problem, and I already got it faster by an easy method called parallelism.
I don't know if Capo knows. We have a little side group that just does hex stuff.
Yeah, and
you know that I think that's the
hex
hex layer.
gang.
Yeah, I saw
It's
you.
a hex
were in
layer.
that
Yeah,
server.
I'm on the server. I'm like contributing some stuff to it. I also tried to like solve it by quantum computing, but I like eventually I didn't continue the development because it's quite hard to like do algorithms in qubit logic. Yeah, but it's amazing. It truly is.
Life is fun.
So
I don't know.
I
I
gave
didn't-
Dennis the link to the GitHub. I don't think that was in the YouTube description.
I
that is
don't
true.
do much hardware, but I really enjoy.
I need to
software.
add that, don't I?
Oh my! What has ROI been doing to VCB? Holy shit! That man.
I have like one thing on my plot. I'm the MC. It's a CCA hexadecimal, which I built for the for the builder rank for the trail. So I'm kinda not using my rank on all.
I don't even know if I still have a rank on or.
There we go. I added the link in the to the get in the description.
It's
Oh,
been a
nice.
decade.
Now everybody can join OR. It's amazing.
I remember taking the test when I was trying to join OR.
Or puns.
Do they
Fit
still
in
do
perfect.
test? Kappa.
Yeah, they still do trials.
Ah.
Yeah, we still have a trial builder.
Interesting. I remember they wanted me to join some school server thingy, and I just said no. I'll just do the test, thank you. But yeah.
We get a lot of newcomers are just very raw, so they have to learn binary and then they have to learn logic and
Oh
adders.
no.
I did the same. I just joined and did the trail and
Yeah, I
was
skipped the
pretty
trial. I
crazy.
skipped school.
Yeah.
Me too.
Me
I
too,
couldn't.
right?
I could already make a CPU before I learned that it existed.
Yeah,
in OR, so.
I built like
Yeah, me too.
I built a multifunction calculator and developed like my own unary style of like base 10 unary of like adder and adder subtractor system and Redstone, and then realized I was like, oh yeah, I can use binary, and like what made all that without even looking on anything online. So I joined Orals. I'm gonna make my own version of a multiplier, and they're like, okay. It took me 4.5 hours. I didn't even finish, but they passed me since they're like, clearly you know what it is. This is just way too big.
Yeah, it was the same for me. For the like, I needed multiple trails because it took too long, and who was trailing me? I guess it was I forgot who it was. But it's like he didn't, the admin didn't have time. Yeah, he didn't have time anymore, so I had to quit my trail. Yeah.
I finished
just fine.
mine in time. Like
It took like more than 2 hours for me. So
I built like a very small compact title 4-bit CPU, and it took like.
I built a ALU and.
Oh, I have to go. Meeting time.
Bye.
I'll just mute. I'll be back afterwards. Yeah.
Bye.
You came in with a hex ALU, right?
Yeah.
Which is very cool.
I like hex a lot. I do just hex. I just do hex.
You're gonna fit in perfectly with the hex gang.
I'm CEO of hex.
All right.
I'm in hex gang already, but it's like just like no interest almost in there. Well, like I am improving right now the algorithm that they got in Rust. To like they got a max of 7 layers. I instant. I improved the algorithm to 8 layers. It's like a lot. But it's still not done. So yeah.
You heard of high signal strength?
What? High signal?
So we abbreviate HSS for high signal strength. So you've got using the internal data in the game, the MBT data, you can put values higher than 15. So,
oh yeah, I know.
And as long as you don't expose the dust, you can keep it inside of comparator loops and do math with that. Now, I don't think that's vanilla enough for me, but that's an area of research that's still mostly.
It's not vanilla enough for me too.
Yeah. You like vanilla or?
Finished. Hello, Optiman.
Yeah.
Oh, Mart.
I was thinking to like make some program to like generate CPUs, if that is possible, but it would be like kind of lame. But that you can like automate creation, or parts at least of CPU creation.
Well, you see this last link that I messaged you, the very
Uh,
rudimentary Verilog to Redstone compiler.
Yeah. Is it? Yeah. Minecraft HDL?
Yeah.
Oh, yeah. See that. Oh, it's that. Oh, okay.
Possibility space for Redstone is so large, of course, but take that to the next step, you'd have to introduce some kind of compacting strategies, you know?
Well, yeah. Oh, the sun is. Ah! The sun is blending me. I can't see my screen.
The sun is a deadly laser.
The sun is a deadly laser.
Deadly laser.
Oh, I don't know
Right.
that meme, but every time I'm at the
You
beach,
don't know it?
Dude, history of the
How
Earth.
you don't need.
What
like,
the
that
fuck?
Everybody knows.
Words?
Billy Woods, yes.
Yeah, I think I've seen that once, but I'm not gonna remember anything from it.
Oh my god.
Why
I know
not?
that I've seen that thing probably 50 times.
It's so good.
If I wasn't worried about like being
Such a good
copyright
video.
striked, I'd stream it right now and just be like, we're watching it.
Can we
Maybe
go,
I'm
man?
a boomer.
Bro,
But I can only
why?
I don't need
The
to watch
sun
that
is
more
a
than
deadly
once.
laser.
Laser.
Okay.
What was that, Optimo?
Before that video existed, I've been saying that's a freaking star right there. Don't even look at it.
Fuck.
You look right at a supernova? No.
My eyes are itchy. Fucking spring.
What's what? How is there
Yeah,
rewatchability
long
on
variable
that
names
until
for
it
the
works the video?
win.
Oh yeah, I'm going to do programming now too. But in Futag.
Futhark. I've seen
Futag.
that name once before. Does that give you
It
functional
is
programming like
amazing.
Pascal?
Yeah, it's like Haskell. Nah, well, it's similar to Haskell, but in Haskell everything is based on recursion. In Futag, you don't have recursion.
Ah,
So you can actually write shaders for GPU, which means you can just do parallel programming really easy for GPU instead of using like C++ and CUDA libraries, which is just a pre-compiler, I guess, for it. Like it's generating C code basically, but it's like easier than programming it yourself because programming for GPU sucks.
Laser. That's gonna be stuck in my head.
Check
now.
it out.
Thanks
And
a
it's
lot.
it this is like one of the this is one of the first languages where I got like 100% of my system really used, like all of it.
like all the
It's,
cores all at the same time.
Yeah, wait, let me show you. Oh, are you on the hex gang? I guess you are. Yeah, you are. Go to other brute force options
Yeah, I saw it.
and
I saw
then
your-
scroll up. Yeah, it's like 100% GPU, 100% CPU, and a lot of RAM.
Not every day you see a graph like that.
It's like it was lagging to use everything. Oh, read
Where is
timeout
that?
exception. It's on other brute force options. Optimizations, other brute force optimizations.
Oh yeah, I don't think they're in Hex Gang, but
I'm in Hex Gang.
oh okay, you are. I don't know if Mart is.
The
Just
what?
scroll up a bit.
You have to be invited, but there's a Hex channel. There's a Hex server.
Yeah, so which channel is it? Oh, it's in brute force optimizations.
Was
Yeah.
that the one that you, Kopo and Ellie were talking about?
No.
Oh, this is one. Everybody's just using comparator logic. Or
I mean, I don't have a bad PC, but it's like my CPU is averaging usually about 2%.
Holy fuck. My eyes.
So, and I have like 64 gigs of RAM,
Oh,
and it using 18 gigs is a lot. And it using the full GPU, GPU VRAM, and my full CPU CUDA cores is also amazing. I don't know how to express that. I have an RTX 2070 Super. It's old, I know, but it's like okay, it's still good.
1D70 Super, that's what I have.
Ah, welcome in the gang.
Yeah, it was just enough to run Stable Diffusion.
We are GPU buddies now.
Although, I'm getting a new 30 series soon. Just got
Yeah, I was thinking too to like move one up because 40 is too expensive. But everybody is selling like all the 4070 gang is like selling the 30 gang 30 version.
I built a new Ryzen machine last year, so I have to put a new GPU in it.
What CPU do you have?
It's a 5900X.
5900.
5600X?
I have 3900X 12 core.
My first time with an AMD, so I was fun to try it.
Ryzen 9 3900X.
Back optimal.
Like
You have
I
more-
don't know. It usually I have enough. Usually my PC is good enough for my purposes. I don't know what the fuck is going on with my hard drive. It's like 100%. I'm not doing anything. Is it like?
I
Back
need
up that
Verilog-
shit
need
now.
logic.
Is it like? I don't know what is this doing? Why is it at 100% right now? It's like
If you're sure
scanning
it's
for
just idle,
viruses. No.
if you're sure it's just idle, maybe it's on the end of his life.
Oh yeah, if you're under 10% on a solid state.
I got 100% on this. I don't know why. I'm not copying anything.
Before we elaborated the hex layer problem, we were using 100% of our brains.
Wow. but why is my hard drive like at averaging around 100%? What the fuck is going on? Really. My 2 terabyte HDD is like getting attacked.
Is that a Samsung 9 series?
I don't think
there's a
so.
patch, there's an update, firmware update for the 2 gigabyte, 2 terabyte, a 970, 980 Samsung.
No, I don't think it's it. Like the SSD is good, but D is like crazy. D is like at 100% right now. It never was before. Okay, well I don't mind, as long as my data is not safety, right? I don't have copies of it.
Back it up.
Well, I use NixOS as a system, so shouldn't be too bad.
Of course, I've heard great things about Nix, but I'm still using
It
my
is
7 years old setup.
It is honestly, it's so good. There are some major drawbacks which let me like say I might not use it. First, you got a package. If you don't have a package that you desire, because it's lacking a lot of packages, you need to make it yourself. You need to like build it. You need to package it yourself, which isn't hard, I guess, but you need to like get into it, and it's not very fun. Instead of like doing just apt install, like
Sure, but I've
making the you know.
I've had to
Then
build
another
source lots of times.
drawback would be you might not want like that's the major drawback. Oh yeah. Second drawback is if one build fails, which sometime can occur if like I'm using unstable, so there are sometimes some project that fails building. Your system just like won't work, so you can't update anymore for the time this isn't fixed. You could
So,
install it, then it would work. But sometimes that's two main drawbacks you get. A good like two plus point. Your system is always up to date. Everything. That's amazing. And you just save your configuration file. So after you like, if you want to reset your PC, go for it, because you don't have too much data on it. You just copy the data off, flush your system, put the configuration file in it, and it's up to it's like working again.
you use the closed source NVIDIA drivers?
If you're big
For what?
I thought you said you had a NVIDIA card. Do you use the drivers that come with it, or do you use the so-called free open source drivers?
I use the drivers that comes with it. Usually, also
The problem, I can't put mine to sleep because of some problem with the NVIDIA drivers.
Never had problems with it. Weird. I'm stealing Lot DiCaprio. What the fuck? His name. I'm stealing your viewers. Wait.
I'm offended.
Capo is the OR admin, by the way.
Yeah, I know.
He's the badmin.
The badman.
This is like, this is the basic code. You need to like make some brute forcing for the
You're streaming.
HLP.
One moment.
Let me make it bigger.
Oh, it's not just me having problems with it. At least yours is fixing itself. Mine isn't.
Oh, the stream, yeah.
I'm double streaming your stream to the world right now, by the way.
Yeah, I know. I saw this.
Because you're talking and I'm just sitting here on my other screen, so I figured, hey, while you're talking, give him something to reference.
Okay. So basically the HLP problem, I'm not, can I would need to change Windows to my full screen, because then I can explain it better. For those who don't know what the HLP problem is you have like one basic element. It's called layer for us mainly, and you can have an input, and by going through these two main comparators, which is one the side input and the second from back, then you have like the max value. You can make functions out of it. So basically, you want to have an input of 2, and you want to get an 8, and for the input of 3, you want to get a 0. You can make this with multiple layers. And what we want to figure out is the shortest way to make our target, what should be the output, to figure out the shortest form to make this. So less layers is good.
I want to give an example of a use case for this that I actually used. I worked with, and that it's actually
Displays.
being used a bunch, is like a 7-segment display where you want to have, you can have a single bit come in, like you have like a 4 come in, and then the output bits are like the lower 4 bits would, like it's 4 bits that control the lower 4 elements of a 7-segment, for instance. So you can just put in like 2 of these stacked one on top of the other, and one of them controls the upper 3 elements, the bottom one controls the bottom 4, and it just maps those numbers. So a 4 would need to have like maybe 1 or 2 of the bottom elements on, so it maps that 4 to like a 6 to have those 2 particular bits on, or something like that. It can do really fancy shit. It's really
Yeah.
awesome. You can go from
And
any
they are-
2 4-bit spaces to any 4-bit. It's pretty much a lookup table in hex, and it can be a variable depth. You can do a 4-bit lookup table in as low as like 1 tick. If it's simple, up to 2. It's
The ROM
amazing.
and a decoder.
Yeah, it's a full lookup table in like 2 and the longest one I've seen is like maybe 4 or 5 ticks. I ended up using this exact thing as the optimization that took my my Connect 4 AI from something that took like 126 ticks down to something that took like 20 ticks.
Basically they are also you can like improve on this thing by having a 2 input hex layer, which is way more complicated to calculate. But you can like have 2 inputs of it and make an XOR gate or whatever you need. Just by having a lookup table.
You could emulate any gate with the table, sure.
Yeah, literally any gate. So one thing that I had the idea is that you could, one thing that I've always wanted to do with this is get an ALU set up where for every bit that you put in, you had I feel like there would be a way to be able to do like hex logic with this. It could be really cool. Like Boolean algebra if you used it just right.
think-
Yeah.
You could use it in a hex control unit.
Well, I think a big drawback is it is the shortest way to make something like this. So it's the fastest way to calculate this thing. But it still will be many ticks, I guess, to like make an XOR or stuff like that. Because there's no short and easy way to make XORs. Or like general operators.
Maybe not for an XOR, but for a compound gate.
Yeah. Yeah, you could make this thing. Maybe you could also just do the full adder already. Like a full adder would be possible, I guess. Yeah. We're currently at like 6 layers is instant. To like get, or like almost instant. It takes less than a minute to get 6 layers calculated of this hex layer problem. But it is proven that we are looking for less than 50 layers to like get all of the combinations there are. So yeah.
Oh, you have upper bounds?
Yeah, there's
What was it?
the current proven upper bound for worst case optimal solution is 50.
Okay.
You can get some fancy shit after like 4 or 5 layers, though.
Yeah,
it's amazing.
But what I'm getting right now is like, in Rust the program is designed to make 6 layers. With Futag you could make about 8 layers to instant. Because instead of calculating everything on your CPU, you calculate everything on your GPU, which is a lot faster. And then there are also suboptimal solutions, which I made one in Python. Somewhere in here. Wait, that's it.
I'm gonna go grab it. I'll be back.
Yeah, so I basically made a suboptimal solution which can make the optimal solution. It's not proven, but I'm pretty sure it's this optimal solution for every easy function. What are easy functions? Easy functions are everything under 15 layers and without recursion in it. So 0808 would be recursion, for
Walker.
example. But like this whatever this is doesn't have recursion. So it would be fine. Well, it has a 7 as recursion, so it might not be fine. But it has at least for every layer without recursion, it can give the optimal solution, which is also quite nice already in instant. So there are also some things possible. And right now we are just doing everything in Futak, which is brain fuck. Because I never programmed functional languages. So we have our comparator here. It's taking like X as an input, S as an input, and the mode as an input. S for side and X for the back input. And it's like unsigned 8 bits. Because signal strength is 4 bits, but we need to have at least 1 byte, so that's the smallest we can get. Yeah, and basically right now it's just without any optimization, iterating through every layer and in the depths of 3 layers. Which is great. Let me pull my code. So I can. Also, the Git repo is public, so everybody can work on it. Okay, I guess I would like to try this version because I made today some changes on my laptop. And I'm quite curious if this is better. So if my Discord crashes, you know why.
Fair enough. I think I
Like,
actually may be done. Assign dirty equals dirty status.
So I'm doing everything for CUDA because my CPU can do CUDA. I'm compiling the code for CUDA. It's compiled, and then I can do like time.main, so we also get how long it took. And then the program. And I'm quite curious if my PC will crash. Because as we see, my CPU is right now averaging about 77%. 95% actually. I don't know how long this will take because it's not optimized. So.
Motherfucker, has that bitch slept yet?
Who?
Sleeping is for the weak.
Yeah, right. We don't sleep.
That was a joke, by the way.
I just saw a friend get online that has like the weirdest sleep schedule. I'm like, why the hell? How the hell are you online?
I just slept 4 hours today, okay? Don't judge.
I slept 6. I wanted to sleep more, but my girlfriend forced me to wake up.
Ah, great, we got an error. It's called you don't have enough memory.
Uh-oh.
Ah, yeah. It was trying to allocate my RAM, but it's like there's a spike for like the CUDA thing. It was trying to allocate it, and then it just failed and dropped down back.
Did it not use shared memory?
No. Wait, what? Why should I use shared memory?
No, I mean, you have however much your GPU has, and then you have the same amount on the CPU side.
Yeah, but my GPU doesn't have enough memory to like allocate everything that I need. I need to put my calculation orders in batches, so I don't overload my CPU, my GPU. I could like use an A100 or Titan to like calculate this thing, but I'm afraid I don't want to do that.
Like the hex layer problem has drove everyone insane. This is great. Just go
Dude,
rent
I got
rent
involved with
some
it for like a
fat
month.
GPU.
That's why I didn't finish my poker thing, because I needed it for my display, and I kept fucking giving me a headache. So I just dipped out and got burned out from trying to figure out how to make the display as optimal as possible.
I've never heard of the hex layer problem. What is this?
What we've been talking about for the last like 30 minutes.
Oh,
Yeah.
I was in a meeting, right? Oh.
Oh, you
Hey,
should have skipped your
well,
meeting then, Myvar. I'm just kidding.
I could have honestly.
You
skipped
could
it,
just
but-
join the Hex gang.
I could have,
Not
honestly. I
gonna
love that.
Yeah, like honestly, it was just a waste of my
Need
time.
an invite.
It probably is, but it's not. After you realized you failed.
I have such a nasty fucking headache.
Yeah.
I'm
The
gonna commit
hex-
murder.
Don't commit suicide. That shit kills you.
Oh, no!
No. Murder, not suicide. Murder.
Okay.
There's a difference.
Moida.
Murder
I
is
don't
when you hurt
know.
someone else. I'm being sarcastic, by the way.
Hey Kappa, if you got Cordis running, I don't know if you do. You could show Dennis what the RTL view looks like.
RTL view?
Yeah, compile this Verilog. Tell Cordis.
Okay. This was okay. Now we see how long it takes to calculate a 3-layer thing. It takes like 0.2 seconds, like 200 milliseconds to do 3 layers, which is
So slow.
it isn't slow actually. No, it's not slow.
I design processors, so if you're getting into milliseconds, it starts being slow.
Well, Kappa would do this on an FPGA. Of course, it's gonna be fast.
Yeah, I would just if I'm gonna be programming something, it'd be much more faster for me to make and faster for me to run if I would just like look at the problem and make an accelerator for it on an FPGA. Wait, why don't we do that for this?
I don't know why. I'm waiting for it. I'm doing it with GPU now.
Well then, okay, here you go. You're here. You're in the learn to do shit. Learn some FPGA and make it. That'd be make an accelerator so you can find the optimal.
FPGAs before.
You're here to learn.
I love this language already to solve the problem. Okay. Type of FPGA are you thinking? Like, I would need to buy an FPGA, right?
No, not for a long time. You can like when you learn it, you don't have to learn it. Actually, buy one for like a long time.
And when you do buy one, you get something like under $300 or something.
300 be a
I have a GPU
between $50 to
already.
$100.
I already have a GPU already, so I don't need to buy a FPGA if I can make it with a GPU.
FPGA will be faster.
Yeah, if you find there's some overhead in CUDA, you might want to, but I don't know.
Well, then have fun designing a FPGA for it. I'm not wasting time on that. I already wasted too much time on CPU and GPU parallelization.
Be a good resume builder project.
Whatever. It takes like 2. Okay. Here's the deal. takes like 2 sec. Yeah, well, this is bad. This is bad because it was like instant, so it has already like most of the time was just setup time. But I guess it will take longer. I don't know, probably not. If I just do it on multi-core. Help me here. Multi-core. Yeah, we want to have multi-core. Okay, let's see how long this will take. It takes longer, you see? It takes longer to make it make the same thing on CPU on my CPU. Took like 10 seconds. And
Well,
all
3 layers in 10 seconds versus 200 milliseconds?
Yeah.
That's pretty good.
Yeah, I know. Right? So instead of 6 layers, you get 8 layers.
By the way, there is a tool chain using Haskell with PGA.
I'm not getting into FPGAs. I already programmed some. Wait, do we have it somewhere here? It's HLP. We already got some quantum algorithms going on. Just for the thing. I was like trying to make it. It was good, I guess. That's like they are expensive, okay? I don't have money. Well, I actually do, but I don't want to spend money on it. I have better use cases for money.
That's how it begins with Hex Gang. And next year
It's
you'll
like a
be
drug.
in a chip fab.
Like getting drug addict to hex numbers. Oh, my next doses of hex. I can overdose on hex though.
I remember seeing Amino on OR for like 30 hours straight working on Hex.
And?
It's just, we were talking about how valuable it is to get some sleep. Hex will take that away from you.
Boy.
Yeah, Amino's like really smart, right? I heard a lot about him.
It impresses me every time I chat with him.
Like he made one of the best builds for like in Minecraft.
Great researcher.
Love doing emergency hot fixes to production after hours. Totally not gonna bite me in the ass. Nope. Because how can it?
Try designing an FPGA for Hex Gang. Have fun. I'm not touching that shit.
Send me a link. I'll go look at it. Maybe it could be fun.
A link for what?
Hmm?
Do you want to have a link?
Yes.
For
No
Hex
problem.
Gang? Here, Optimo, you just send them because
If
you already...
I can't invite you. I'm not the admin.
Verilog. Imagine.
I just
Just-
want a link to the problem. Like, or is it like a? How do I get information?
It's a Discord server.
It's a novel problem.
Yeah,
A novel
it's
problem.
it is proven to be NP hard, and we are unsure if it's NP complete. But I think it's NP complete. So
I'll
Yeah.
ask. I'll see if someone can invite you.
Okay.
I could.
Work like that?
No, invites are disabled. Ah,
Yeah.
fuck. Shark.
Is there a description of the problem on that Discord?
Yeah, it is. There is. Actually, I got invited. I don't know how I got invited, and I don't know why I got invited.
I think Lesbian invited you.
Who?
She's admin.
Well, yeah, someone invited me because I like Hex, and Hex is POC.
What is hex in this context?
It's
It is hexadecimal. It's like 0 to 15 or 4
Yeah, I know what hex
but
is. But
binary
like,
digits or like
how
could
is
be so much.
hexadecimal a problem? That's what I'm trying to say. Like, what's the context?
Like the problem is in Minecraft we got like this hex layer things where you can like use comparators to like subtract and invert signals, you know, and running calculations with comparators. And our goal is to find the shortest way to like use these comparator logic to like generate every possible output and calculate the shortest comparator combination
I see.
or permutation with it.
I see. Can you hear me?
What the fuck?
Vana?
What?
Do you need
Yeah.
help?
Yes. My soul is broken.
The new film using the remix of that song, right?
Uh-huh. I don't know. Okay.
Try going outside.
Can you see the side
I
chat
did.
here?
Yeah. Sure.
Oh yeah.
Some info from
Why
the
am I pinged?
just so you can verify if I'm missing something.
No, I don't think so. Yeah, that's everything.
Myvar, the brown things, those are called barrels, okay? And they can have.
I know what a barrel is. Yeah.
Okay, each can have a nibble, right? Then the only other option is you can toggle the comparator on to subtraction mode or not. So those are your only variables. 2 nibbles and the mode of the comparator. And the chaining of the layers.
Is each layer one of these diagonal thingies?
Yeah, no, yeah, like the one thing is a layer that on the one image.
Single part.
And you got repetition of it.
Any of them for a layer.
On the right.
Do I have Minecraft on my computer? So, in other words, what you're asking is, do you put different nibbles in those barrels? And
Yes.
then it solves a problem.
Yeah, you can like make every combination. If you want to like have you have like you're like inputting 1 into like a nibble of with a value of 1 on the
four demux, right?
Yeah, and then you get like an output, and you want to have a desired output. You want to like have 4 as an output, and you need to calculate that.
Okay.
And you want to have the optimal solution. You don't want to have a suboptimal, because suboptimal would be so easy.
Very first barrel on the bottom, that would be your input.
Yeah. Oh, and then you want to design a comparator, a bunch of inputs that would yield some kind of an output? Like, where does the output come from?
Top dust. Very end.
Yeah, but who decides what the output should be? Like,
what kind of ROM you want? Okay, so you put in some nibble in the back, and you get some nibble in the front and back. One in the input, one in the output. So any nibble to any nibble.
Yeah, but that just sounds like it's either 1 or 0.
So it's any SS value 0 to 15 comes
0
up to
15.
Oh.
You work with signal strength.
Yeah, okay. I still don't understand, but I will in a moment, I guess.
And build any complicated lookup table with this.
We love lookup tables.
Yeah. So, but what is the point of the other barrels?
You just like subtract or add the value of the barrels that you have there.
As the input cascades through this, the barrel values and the equals will change that value.
Yeah.
Yeah, okay, I understand that, but like what I'm trying to get together is why would you have an entire chain if you're just going from 0 to 16 on that with single output? There's only one output.
A linear map. It's like a convolution.
If you
Yeah,
want to
it's
have
not
like
a
zero,
straightforward map. You could have your output map like 0 to 1 to being like a binary sequence on prime numbers or something like that. You could do any arbitrary sequence. You could have it be like the output 1, 2, 3, 4, 5, 6, 1 to F be mapped to like F,
Sorry,
2, 7, 12, T. Like you just go anywhere you want.
I think, but I think what's going on here is I'm thinking of the final state of this thing. What you're saying is it pulses in different. It pulses in different sequences.
yeah. Kinda.
Yeah. Okay. That
No,
makes-
you have a constant input and you get a constant output.
It's
Oh.
literally a lookup table, a 4-bit input to a 4-bit output mapping. It can be any mapping you want. It's just a 1
Yeah,
to
but
1 mapping.
where do you input the 4 bits?
At the beginning, you input the 4 bits. At the very first
Dust.
input.
Oh.
It can represent 4 bits.
Okay, let's build this, and then I'm gonna explain with it. Let's do that. Okay.
I have it on my plot already. If you want to.
This has been worked on for years of like random research.
Nice.
And
Not
they
making me feel
I can't believe that.
confident. There are some problems that are really difficult to do.
They are just they are optimizing it, but they are not using like you could use parallelism, which is the easiest optimization. They are
Right,
not-
did I build that correctly? I think so.
This
Yeah.
makes me angry. She could at least try to make it faster.
So do you put stackable items or non-stackable items in it?
You
Whatever you like to get the number you need.
Yeah,
are
it
you
doesn't
on
really
Ore?
matter.
No, I'm not on Ore. I guess I could go to Ore.
yeah,
No,
you
or-
should go to you should go to school.
What version of Minecraft is Ore on now?
118.2. 118.2.
Okay. 118.2. Thank you.
Are you using poly? Why are you using poly?
Because multi-MC has problems.
Why aren't you using like Minecraft? Usual.
Oh, because I exclusively use Linux.
Huh.
So.
Wait, what? You have Windows, right?
Yeah, I'm on Windows right now because for work. Like I said, I'm busy patching. I'm busy patching production stuff.
But I'm so confused. But why are you now using poly if you could use?
Because it gives me a consistent experience between platforms.
Okay, got it.
Yeah.
Yeah, I have poly too on Linux.
Yeah.
It's the one that had a hostile takeover of their source code.
I don't know.
There's it's open source.
The Yang logging, the Microsoft account logging stuff broke on multi-MC, so, and I just googled an alternative and poly-MC came out. I think it's a fork by the looks of things.
It's a both. Yeah. GUI. Yeah, right.
Dennis, do you have we share around a chest with all the barrels in it? All the values?
Yeah, I do.
Okay. I end up putting that on saved toolbars. It just makes it faster. Each barrel.
Oh, really?
What's the OR server's IP?
It's
MC.
openredstone.org.
Thank you.
yeah. There you go.
There. Let's see if I even have a plot. Oh, I do have a
Oh,
plot.
you do.
Yeah. Yeah, okay.
But it's the old one, right?
Oh, I think I'm in the new world. I did join and screw around with stuff for a short while there.
Just TP to
come
me.
on.
Just to just go on
Dennis,
school.
yeah.
No, that is not how it works. You need to like go first on school because I'm not on.
Oh, you're not on. I
Yeah,
don't get
because I have
school.
all my main. Wait, where's my? Actually,
School. Okay.
oh yeah, I'm on the school because I don't transfer it to my build plot, so why not?
Hi,
Anyway.
RT.
Now you.
Do easily. We have schematic server. Save your
Slash the trust
What?
my.
Yeah, Redstone has changed so much since I've actually done Redstone. Holy shit.
So those lecterns are just like a portable hex selector.
Ah, I hear
If
you.
you change
Yeah.
the page, it reads the page number.
Don't go through this shit. It's not amazing.
No, no,
This
Just
is
show them the
also.
basics.
I have too much stuff on here. Okay, so basically you got this thing. Yeah. You need to learn flies. Okay, basically you have like one input here. It's like over lecterns right now. I don't know if you have a texture pack. I don't think so.
no,
No, you don't.
I don't.
But basically you have an input value on here. So
Yeah.
every lectern is an input. This is my X input for this layer or for the function. These two on the sides are like the side inputs or like the layer variables.
Oh, I see. This structure here is that same structure.
Yeah. And in the middle you have like you can like turn on and turn it off. And then you can like put side inputs from 0 to 15.
Okay. So what constitutes the input bits in a chain of these, like over here? So these on the side. So this would be 3 bits of input.
Oh, these are each a nibble.
A nibble. Oh, so does this form like decoders almost?
Yeah, you can put
So
a
the
value.
problem is writing a program to generate a lookup table.
Yeah, right.
Or we're
To
writing a
generate this
program
thing to make the
store the
lookup
short
table
answers.
work. You have the lookup table and you want to have this thing as short as possible.
Okay, and so in other words, what the program needs to output is what the values of these books are on the side.
And if the comparator's on or off.
Okay, and then one thing I want to understand is how do you use this lookup table in a normal redstone circuit?
That's why I gave the example of the display of
You
where
could
if you
use a display for it or like a 7 segment.
Yeah, but
display.
demonstrate to me. Where do I input the number and where do I get the
You
output?
put here the number in. This is your input.
Yeah.
And
So-
here you get it out.
I think if you do / warp
Ah.
poke or you'll see some displays. And also I know there's some people that do have displays.
Yeah.
On both server.
It's
Yeah.
built.
Okay, that makes sense. So in other words, you have a 16 lookup table with 16 slots.
Yeah. 4 bits in, 4 bits
Oh.
out.
That's sorry, you said poke. Is that it? I remember you making poker.
Yeah, I think it's like poke or.
No.
To go on build and then you gotta type / warp or something.
Hold on, I'll load up Minecraft.
Woo.
Okay, I
Everything
understand. So, and then the problem space is finding. Oh, I see. It's a non-polynomial problem because every input influences every.
Yeah. But we don't know the hardness for exact.
I
no,
understand.
This fine. I think it's NP complete. Many people think it's just NP hard. Or like what means just it's NP hard.
Yeah. Okay. So the problem is finding a. But it's only in one direction. The input value things only propagate in one direction. So.
Yeah, but
full NP scope, like.
Where you could the it just goes in one direction.
Yeah. Like if it went
Actually, I'm
backwards.
curious what would have what would
Do you need
what
me to
would
load
happen
Minecraft
if
up?
you.
Yes or no?
No,
Huh?
it's good.
Okay, good.
No,
I'm curious
I
what
don't
would
wanna.
happen if you have like your like your layers inverted. What would happen? I don't know.
So how many? So does the computer program that you need to write also describe how many layers there are?
Well, you need to brute force it because you don't know how many layers there are until you got
Okay,
it.
so
It's still
that's-
NP hard.
yeah. So in other words, I can choose how many layers there are. I can choose the barrels.
No, you don't
config.
choose how many layers there are. You determine how many layers there are needed to solve
Yeah,
it.
but that's still my software telling me how many layers there are, right?
Yeah, yes.
So I choose the layers. I choose the
Barrels
subtraction
and
or
yeah,
addition, and I choose the values of the barrels.
right.
And then I should be able to make an arbitrary lookup table that has 16 values.
Right. That's the whole problem. You got it. Congrats.
Ivar, I gave you an invite.
I joined. Thank you.
Okay, cool.
It should be fairly straightforward to write a brute forcing thing for this. That would work.
What? Where are you?
Oh, I'll go home. You can warp to my empty plot, I guess, if you want to. Just TP to me.
Oh,
Well,
mine is
okay.
just as empty as yours.
Yeah, I used to have like huge computers and stuff, but I haven't played in a very, very long time. Right.
Like if you go to my plot, wait. Okay.
Right. Where is the barrel?
Okay, it's gonna take you forever without the presets.
You can just do /containers.
Flash container and then the type of container and then value.
Barrel
Oh,
And
that's
then-
nice.
2, for example.
It's a nice shortcut. I also have every value as a saved preset in my toolbar.
And then can I like what's that thing where you copy something with metadata?
Yes,
Oh, that's
control.
cool. Yeah, control. Yeah. Okay, that makes sense. So yeah, this is interesting. It's interesting, but I don't. It would be extremely difficult to make a.
Is the most compact technology for this arbitrary lookup table.
Yeah, but it doesn't have a lot of space. It's a very small lookup table, right?
It's 4 bits to 4 bits. That can take any number of steps to convolute it into the result you're after.
Well, yeah, but like 4 to 4. Yes. I hear you. Yeah, 16 to 16. There are 16 entries in the table. Yeah. That's small, but yeah, I get you. But you could have multiple of these tables and stuff, and then like hook up a table to a table in a decoder, I guess. Anyway,
I mean, each layer is essentially that.
Yeah. Okay. So. This is the fundamental design, right? Oh, very easy to copy with welded it. Yeah.
If you look forward and diagonal, you can stack it. It might stack it diagonally.
Oh
It's
my
possible.
god.
Oh, that didn't work.
Hold on, did I have that? Let me see.
Paste -A for Reserve air.
I haven't used World Edit since I
Oh
was
yeah,
a
so
teenager.
I do have it not setting for stores.
I'm very tempted to jump in to help you.
Come on, join me. I know you wanna. Come on. Let's stick around. I know you wanna. Yeah.
Yeah, yeah.
Uh-huh.
It's just I gotta go other machine.
Are you intruding me?
Hmm?
What? You're like now building the layers, right?
Yes.
Do you want to try out stuff with it?
Do you want
You
to try
put-
out what?
Yeah, what is your goal right now?
Oh, I'm just trying to wrap my head around how the comparators interact.
Oh, okay.
Yeah, yeah.
Well, it's I figured out there are 4 functions that you can make with it.
Moving from a.
Cool.
But if you go on the hex gang, well, you aren't on the hex gang, but if you are there, they
I am.
figured out some main functions that you can do with it, or
Yeah,
some
yeah,
main
that makes sense.
correlations.
A big part of it is just screwing around right now. I'll let other people's ideas sink in once I've formed my
Yeah,
own.
my VAR doesn't have a lot of time for redstone lately.
Yeah.
What is redstone? Right?
Just in general,
Redstone?
he's not played this in a while.
Yeah, in a very long while.
We don't know what redstone is.
Oh.
No,
No
we don't.
experience.
Just trying to figure out how to stack this thing in a sane way.
I don't know what this question was for the application, but I needed to answer. Why do I like redstone? I was just like, okay, it's Turing complete. That's a plus.
It's a good answer. It's a really informative answer. It shows your.
Oh, that's interesting how that's stacked.
I got accepted.
Most newcomers don't even know what Turing completeness is.
Oh.
That's pretty wild.
The student rank is to start from nothing and then go the entire CS 101 experience.
Yeah, skip the student rank, right?
Yeah.
You don't need to be student. Do you have a degree in something already, or are you still studying?
I don't have a degree in anything.
Oh.
It's like he's trying to figure out how to stack it, which is not always easy.
Yeah. But I'm a programmer by profession. Like, I do professionally program.
Look
But not
diagonally and
right. Please don't say you're a web developer.
No, I program self-driving cars.
I don't know why, but being a web developer sucks.
It does. I do web development on the side for extra money, but
Yeah, well, I don't do. Well, I do development for money, but I'm not doing web development because
okay, so that's stacked, right?
I hate web development.
Yeah, it's not cool. It's really bad. Okay, and then we put those.
Nice. You stacked.
And I think these get barrels as well, right?
Yeah, right.
Why am I lagging so much? What the hell? Oh, I probably should put on. No, that's the VSync's probably on, right? Yeah, screw you. There we go. Oh, much better. Okay. Nope, still lagging. Okay. And then this one needs a thing. So did I do that correct? I think that's correct, right? That's the basic setup.
Yeah.
Yeah,
right.
except
that
that
are
you can
already
have
4 layers, but it's like
yeah. You can have many layers. So now, if I want to understand this output, I can do. Can redstone travel up a lamp? I can't remember. There's something about that.
Lamps are
It's not-
diodes.
Ah, okay, but they can't travel down or something. I can't.
Yeah, they can't
was-
travel down their diodes.
Cool.
Yeah.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right. So in effect, if I put a value in there, this is where the console what's it called? The podium that the villagers use. Man,
Capital streams.
lectern. That's the word. Haha.
Oh yeah, like, and then you need a book with 15 entries.
Can I get a?
I have
Trainer for
a
that?
book.
Okay, I'm gonna switch to my phone. I'm gonna jump in the game.
Excuse me.
Cool,
Bye.
cool. Come join me, mate. Let's do some problem solving. Yeah. Okay. 1, 2, 3, 4, 5, 9, 10, 15. Right? 15 pages. Alright, so doing nothing will literally just propagate the number all the way through, right? I think that, yes.
Right.
Yeah, that propagates the number all the way through. Hello, Optimo.
Hello.
How you doing, mate? You were gone for 5 seconds.
I know. So quick.
Right, so not modifying any of the input. So now, yeah, you can just TP to me. There we go. Okay. So now, so the output, quickly cycle the book. I want to see what happens. The input book.
See this?
Yeah. Oh, where did you get this? And can I marry you?
You can keep that. You can control, click it, save it in your toolbar. You know how to do save toolbars?
No, it's good. I'll just plop it down there and then have one for life. There we go. But yeah, the book is easy to mess with right now, right? Okay.
Yep.
So if I grab an MBT value of 1, right? An MBT value of 1. Oh, I should be duplicating that out or something. I don't know.
You should be able to middle click on it.
Yeah. Okay. Well, anyway, I stole the one. You can just copy, duplicate this original one here. Get back your. Yeah. Okay. So if we were to install that over here. So at the moment the value is 4, and we remove that, the value stays 4. Why did the value not change? Probably because no, that doesn't do jack shit.
The 4 gets pushed right through this block.
Yeah, the 4. Okay.
And then also, this one is wrong.
Oh, did I do something wrong? No. Oh, why is it twice like that? The fuck?
This is the correct design here.
That's how what's on the screenshot.
Oh, sorry, you're right. I'm looking at it backwards.
Ah. I think that might be going on here is that oh yeah, okay. I don't quite understand how comparator works.
Okay.
Comparators
by
only came
default-
along after I started.
So when you set one down by default, it's in compare mode, right?
Okay.
It'll take the back input. It compares it to the side input. If the back input is greater than or equal to the side, the back input will go through. Okay.
And if it's not, oh, so it doesn't actually do any subtraction or addition. It only does comparison.
But now, if you right-click this, you turn this on. Now it's in subtraction mode. Now it does subtraction. Unconditionally.
Unconditionally. Oh, so in other words, if I was to take this input value of 1 and subtract it. Oh, that doesn't do jack shit because it can't subtract from the cable. So where is the main? So must the 1 be on this barrel then? I don't understand.
Here you're getting a 1 minus 4, but the 4 is also going through and overriding on the side.
I see that, yeah. Yeah, because it's 4.
That's part of the magic.
Ah, I hear you.
I'll be
Can
right
we?
back.
This is a very compact design. Can we make a not compact design, but that doesn't have this overlappingness going on? So in other words, what's really going on here is something that's closer to this, like this, right? So can I get an empty barrel? One moment. An empty barrel. Here.
I feel like this stream
So-
is 80 in the last like 30 minutes, 30, 40 minutes has been 80% you guys talking about Minecraft stuff while I'm just been silently coding my this processor, like not talking about shit.
Basically.
Yeah.
But the good thing is that the Runahead register state should be done.
Oh, good.
It
No,
should
this is
be.
not working.
You gotta
Because
write
all
a
the
test bed.
inputs are managed. It's just a lot of inputs in this thing. It's just a generic register state system that's gonna. It just tracks register state and it outputs whether it's dirty. Each register is to be written or to be read. So I can then use this logic in the in this check here, in this operand, this clean operand system. There's gonna be pretty much this check here.
Mm.
Then I used these like conditions underneath it to end up defining what I needed to do over there.
That makes sense. Is that
Well-
the same thing, Optimo?
Well, okay. Importantly, critically, in fact, you can't have any dust runs of longer than one because that changes the value.
Okay, I respect that, but
Yeah, you can't think of it like binary circuits.
yeah. No, I get that, but is this the way it connects, right? I think this is the way it connects.
Yeah, this one would override it. Yeah.
Yeah, so in other words, this is the output, this line here, and effectively, let's call this one A. This could be a shulker box, right, instead of a barrel.
Yeah, any container you like.
Because then you could have different colors. So let's go shulker boxes, right? And say that we have a green and a red input. Okay, so we have a green side of this equation, and now it's easier to talk about what's going on, right?
Sure.
So we could do the same here. The reds are all on this side, and the greens are all on this side. There's one extra. Oh no, this green one here represents the input, I guess. So let's just put one at the bottom there to say that one's, it's a red, right?
Red, yeah.
Yeah, okay. So what's going on here is that the green has a side input that is the same front input of the red one. The red second one. Oh. So what is this comparator to? Like this one. How is it contributing to the solution?
This only reads the box and gives you a value because it has to come out in a straight line.
Yeah, but what happens when you put it on the subtraction mode?
On this one, nothing. It just reads the box. There's no change.
Oh, because you cannot put the box there. I see.
Correct.
Yeah. That makes a lot of sense. Okay, that makes a lot of sense. Okay, so in other words, we're not thinking about this one and the one. So let's stop thinking about it in this imaginary diagram, right? To keep things easy. So in other words, we have two comparators. One that's so yeah, okay, then we need two new concepts. We need a concept that's describing the input and output, which let's make that black and white. So black and white. Okay, so we have two new concepts here. And the idea here is that, can you just place the dust where I break it, right? Oh, but you can't represent that like that. But effectively, the output becomes the input of the next one, right?
Yeah, I mean, you could just think of this as a function, like Dennis was showing.
Yeah, I get that.
Each part is a little function.
Mm.
So you have a back input and a side input and a toggle, and that's the only variable.
Variable. Mm. I'm just trying to understand how those variables influence the input. I get what you're saying. So in other words, by modifying some of these combinatory variables of a given layer, it will take some input, which we can mark as black, right, and do a function to the output, whether that be subtract a number, append a number, add a number, or some other.
Oh.
Yeah, it can only do subtraction inherently, or
Yes.
override. It can do overrides if it's a higher value on the dust.
So that's it. We can subtract or override.
Yeah.
Okay, so let's start by subtracting. Oh yeah, so let's start by subtracting from the number 4. Let's subtract the value 5. So I should have the value. I have the value 5. Sorry, I currently have the value 5 loaded. There are 1, 2, 3, 4, 5 lights lighted up. So now let's get a value subtracted from that, right? So I'm gonna put some cancels down here. Oh, yeah, that makes sense. You can move it down, yeah.
How's it going?
Okay, like that, right?
Yeah, we're just going through it because my VAR has not even used comparators, it sounds like.
Yeah, no, it's been like I was building redstone computers before comparators existed. It's been a really long time. Okay. Yeah, so I currently have the value of 1, 2, 3, 4, 5 on the output.
Yeah.
Now I want to subtract the value of some value from it. So I want to subtract the value of 3 from it. So that would mean toggling this. No. Which one is the actual overriding one?
Sorry, 1 second. I gotta pull up a screen real quick.
Cool.
Hey, Dennis.
Yeah.
As my understanding is you could toggle either comparator, right? So there's actually 2 toggles?
Yeah.
Okay, not just the one toggle.
No.
Yeah, so you can toggle either of those and change the function. Alright, so you have a 5 coming in.
I just made a salad, but it's bitter. I don't know why.
Okay, 5 coming in. So in other words, we currently have a 5 on this bit of redstone here, right?
Yeah.
Yeah.
So you could put a 3 here and put this on subtract mode. Okay.
So I muted and deafened Discord for a little bit. Where do I get pinged? So in the last hour or so while they were talking about all of that redstone and such, I have been finishing up the register status, which keeps track of the when to it tells the system, it gives the system statuses to know when you forward an instruction to the Runahead queue, when do you stall, when do you uninstall the system, when can you issue from the Runahead queue, and it just how do I generate all those different things, different conditions, and all of those conditions can all be generated with these bits, just with these vectors being indexed by the register addresses when they're used. So this just tracks the state, so that way those can be used elsewhere. And yeah, these I may do a yeah, so since this will be inside the registers themselves, I'll probably end up just turning these addresses into 15-bit vectors, 16-bit vectors, just so I can just don't have to have two decoders. But yeah, this whenever you issue an instruction based on whether or not the operand is being used as an A or a B, a register is being used as an A or B operand, it will mark the register as dirty when it's used as a multi-cycle A operand, and cleared whenever you write, as long as there's not an active mark dirty situation. For to be written, you write to be written under two circumstances. One, if you're not dirty and you're just doing a blanket just write to A and it's not dirty at all, or if you are dirty, then you're writing to A. And you're already dirty, then you can mark this as written. Because if you're so this allows you to write dirt whenever you're issuing. If something's already dirty, it'll do I need to mark this dirty then? Because to be written would be anytime something is to be written. But if something is already dirty and I go to write to it again, okay, yeah, that's why. Because when you because if anything's written, if something is marked as to be written, it's stalled if you try to access it. However, if it's dirty, it's supposed to mark it to be written. So this is like a two-stage write dependency, where you know this one's going to come back at a set amount of time, and you have no idea when this one will come back. And this ensures that if you're just writing in general and you're not doing that, then this needs to be set so you can't write overwrite. But if you're dirty, then you can go here. Yep, because the thing with this is I don't need a to be like a quote unquote dirty for regular operations that aren't marked dirty but still write to A, because those operations are covered in this basic loop over here where the forward kicks in. So that's just covered right there instantly at all times. But yeah, to be written, then to be read is a counter, because if you ever try to write to something that needs to be read, you don't want to write over that, because that's a write after read hazard. So you need to this keeps track of how many current operations in the Runahead queue are going to be reading from that register. So as things get retired, you can then decrement the counter. It can make sure that way, hey, if something's waiting on this register to be cleared, it actually has to be cleared first before you can write to it. Which means Okay, yeah, A to be read and not to be written. I have it covered right there. Awesome. Yeah, so if you're running, if you're clean, both your operands are clean, sweet. But if you need to read from A and A is being written to, then nope, sorry. I don't even need, hold on. This doesn't need to be a condition. If it can never be issued if A is to be written. What instructions would that limit? Is there any instructions that would be waiting for B to be clean that wouldn't care? That doesn't. If you use, yeah, because even if you just read, if you don't read from A, like here where it's just a source, or like a store where it's just a source, or where it's just the destination, so you don't read it. You don't want that to go if it's to be written. Hold on. No, that's stupid. Then the CPU would literally stall and never run because it's stalling if A or B ever hits a to be written. So you never need to check if the head of the run ahead is to be written, because if that was ever set for a register, it would never have even gone to the run ahead queue in the first place because it would have been stalled out. So I don't even need to check that. Coolio, Julio. Yeah, I'm happy with this. But for this stack, since there's a pipeline involved with the stack register, and I'm emulating a top-up stack, I have to be able to keep a transaction queue that keeps track of how long different transactions are out. So if you do like a write or something like that, or if you do a push, 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 and they're all loads, there needs to be a transaction queue for the stack. I think I'll need to split this into 2 separate queues. So if you're operating on the stack, okay. Instructions issued from Runahead Queue do not modify during. Okay, the stack cache, I want to make a note of that. So the stack cache will, if you add something in here and you realize, hey, I need a value, the stat when you're issuing your instruction that the operand you needed for your stack operation, like your B operand, was dirty, or vice versa. Yeah, they are still talking. If the operands are different, if the operand, like, since whenever you issue the instruction for the first time, it's going to already have an entry in this transaction queue. I really don't want to have to be forced to do stack instructions in order. It's gotta be a way. Hold on. If you're issuing an instruction to the stack, you're only going to have to ever be waiting on one operand, if anything. The value you move to the operand. I'm thinking. How can I make this stack queue, transaction queue? If I push things to it, I know I could just tag any operations that use the stack, but then that's a whole other variable that I have to send through. I don't want to send that through. Then, like, my load system would need to keep track of a stack pointer, or a stack transaction ID. Is that worth it? That would be, let's say, 4 bits wider here. I would need a 4-bit wider bus here, because I would just have a limit of 16. I wouldn't go too crazy with the depth. If it went any larger than that, it would be forced to stall. Like 3 to 4 bits deep here. 3 to 4 more bits here, and then all of these operations from here could just grab straight from this. That wouldn't be large there. But then this one, all of these operations would need to have extra metadata. Now, they already do. They already have a register. For loads, they already have a register. For stores, I don't think I really care. Because loads, once a load reaches past here, all I have to do is make sure that if the operand's valid. So that's just pretty much marking it as to be read and making sure the value. Okay. So every transaction queue So this is not gonna work. So what I need is a read queue. Which pushes addresses of all the reads. That way if you read, or if you store something and that operand wasn't available, the only way that wouldn't be available is if the stack operand was invalid because it was on one of the right queues, or if the register was invalid. Okay. Read queue would be all the addresses it's reading from. And you would just push values into there and rotate around. Okay, so generate tags from a one hot. So that way if you read from something, the pointer. Yeah. So for read queue, I need a 3-bit counter and a 4-bit counter. If a 3-bit counter would count how deep it's going, how many max reads are in flight, and then that the 4-bit one hot would allocate which tags. Okay, so I can do 3x 16-bit. To be read. To be written. Are they still talking about the redstone stuff? Oh, you guys stopped talking about the redstone stuff.
Still.
Hi. I've been trying to figure out what I need to do to monitor my stack state because I don't want to. With all the Runahead stuff, monitoring the top of the stack becomes a very complicated thing.
I just do precalc on false. Why can't I use the precalc algorithm?
I actually think this CPU could be smaller than the last one, even though it's like way more complicated.
Okay.
I wonder if there's a Python library to convert redstone circuits into Python code.
That seems like it'd be so fucking difficult.
What, you think that converts?
You'd want it to go through a schematic file and figure out the circuit?
No, not necessarily. So that would be one way, yes. Oh, actually, that would be pretty straightforward to write, huh? But yeah, that or making it really easy to just give the layout in Python.
I did. I did. I don't know if you're watching my stream. Hello?
Hi. Huh, 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 huh,
Alright,
huh.
turn it into some Python, I see. Yeah.
So I just give in this values as a string and I get out the full function.
That is horrible, but nice.
Why is it horrible?
Why would you just input an array on both sides?
Because it's faster that way.
How
You
often
could-
is faster?
You could also do array, but it's like it looks like no. It would like be array would be like that. To it just look like that.
I think I'm gonna start by writing that, but he wrote it different.
Yeah, the main CPU is only 1500 before. Let's see what's the biggest culprit in there. The register file is the largest. At 526. Why is it 526?
What the fuck is going on? 0, 14 on.
Oh my god, yeah. The CPU will be smaller simply because the register file won't be that awful.
That's pretty cool, dude.
Okay, actually it works. I guess I know what I did wrong.
I'm debating whether or not to remove my favorite way of that I can reset registers using synchronous resets and just having since I already have a flash routine that goes in, have the flash routine then send like just 8 instructions into the CPU that just write 0 to all the registers. Like I think having a dedicated little subroutine for it and after the reset system, before it turns on this main CPU, of just writing 0 to all 16 of the registers. I think wasting those 16 cycles is worth it, having a more compact, just using straight RAM for registers, just a dual read RAM module. It'd be much easier, since all my complexity will be in this register status system. I want to actually compile that right now and see how big that will be. Files.
Devis, I didn't really look at your code before, but are you using both toggles in your function?
Yeah.
Okay. Because I remember I saw the declaration the other night. It said just the one boolean, right?
Could you see that? I'm streaming, so I don't.
What? Oh, that's gonna be a fucking syntax error.
Could change this again to something more useful like this.
No, I didn't want to press that button. I didn't want to press it. I pressed the wrong compile button. I pressed the full compile button. No, I can cancel it, but now I just have to like wait for like a minute and a half for it to like start the compile.
I forgot how Python works. Okay. Okay, it's working now. Good. Well,
And you're only using the one boolean, right?
huh? Oh, what am I? Okay, what happens if we get a... Oh, yeah. Makes sense. You get a whole different logic. Yeah, expected. Basically, you could also see at my code that I can like predict easy layers. Easy layer would be this would be an easy layer or easy function. This
Because
would
of
be an
the
easy function.
because of the run length repetition.
Like there's no repetition in it.
Right.
Like you get, if you get like 0808, you have like you're like repeating it over and over, which makes it hard. But for every easy function, it's like the 6 layers, this thing is still easy function even if you got the 7 thing wise. But I could predict it in the optimal function. I guess these aren't. No. The last one is this one. This one is again a 2-layer function, which is easy.
Oh, that's cool. Just stick the 0 at the end.
Yeah.
La 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 la. Okay.
I implemented them.
Yeah. Yes. See.
And yeah, this works quite good. easiest way to make redstone circuits possible.
Let me see. Yeah. What is that function?
You want to have a function, you put in your parameters, and you get your function out.
What are those parameters?
It's like input left, like the barrel left, barrel right, then the toggles. And then you divide it by space, and then you do the same thing for how many layers you need.
Oh, I have something very different in mind. That's
And you could also do just like this programming, you could input the layers directly without using it.
Since they're working on their own stuff, I am going to take a quick. My left ear enjoys this stream. I know, right, Zebek? I need to. Oh, thank you. I forgot to fix that. How about now? If you're still here, Zebek. Testing, testing. I think by making it, downgrading it to mono, it should fix it, because it's only a mono mic, but if I mono, it should make it. That should work, hopefully. Oh. Oh, that's why. Yeah, I'm gonna rename this actually.
I'm done with the redstone for now. Let's focus on what Kappa's doing.
Yeah. Well, I'm stopping this in like 30 minutes, like maybe 15 minutes. I got stuffs to do.
Yeah, my body hurts. I've been sitting for 14 hours, so I should probably stand up at some point.
I do 30 minutes.
Yeah, I'm supposed to do that, but I'm a piece of shit.
I'm going
Have you
off,
tried
man.
You ever
I
explored
gotta go.
the idea of a treadmill computer?
Yeah, I'm thinking of getting a standing desk. So.
Dude, I got 3. I love my standing desks, but I never got the long enough cables. My room's a mess, or they've never stood up.
That's funny.
Yeah, when I move though, I'll have more space.
I got all the cables under my desk sitting, so like I just have one power plug, and I can move my table wherever I want.
Does it look real nice?
It does. Pretty clean.
I'm just curious what type of resource usage this has, and then I'm gonna get off.
I'm getting off now. Bye.
Bye.
Bye, Dennis.
Enjoy your life, mate.
That was awesome. He joined the stream once I posted on Aura, and then just pretty much joined in and stayed with us the entire time.
Yeah, that's pretty cool.
Oh, wow.
He just came to Aura a few days ago.
There's a combinational loop there, buddy.
You sound like Abby.
Mark Dirty.
Are we still live?
Yeah.
Capu's starting to sound like Ellie, or is Ellie sounding like Capu?
That's the question.
I'll be right back. Okay.
Can write
Very
code
last.
in C++ and then use it from Java.
Question.
Yes.
Can one of you check my stream and see if my audio is only coming through the left channel still?
I will, because I'm a nice person.
I only have one speaker, so I can't do that.
Well, which channel is it connected to?
No,
Both.
it's a mono speaker. It's connected to both.
Oh.
Yeah,
See,
no.
I just checked the box of make mono in the mic settings, so that way it should.
The audio is good. It's coming from
Okay,
both.
thank you. So that did fix it. Cool.
I got this Mac Mini. It only has one speaker.
So this looks like it should all work. Oh yeah, and Cordis, tell me.
I hate Cortis. It never wants to accept my
Now that I've looked at, not even looked at, had the
Vivado.
experience of installing Vivado.
I have to go. Goodbye.
Is a lifesaver.
Oh my god, I was about to lose my fucking shit.
About
Because it said my fucking... Look at this. It says my resources was going to be 2,000 for these register status. I was like, what the shit? And then I realized, oh, literally like 1,800 of those are used here. So if I add up these, it's 15 plus 6. It's just a handful.
1,800 are used where?
Or just using my signal tap and stuff like that. Like just
that
quarter
overhead,
stuff.
yeah.
Yeah, so I'm going to do this math, which I...
Only using about 225 ALUTs.
Yeah.
Math.
Hello, Ellie.
Hello.
Yeah, 133.
Imagine.
Okay, I'm happy with 133. That's good, 'cause I need 2 of these units, and these 2 are going to be, like, the more annoying ones.
Imagine. LL1 recursive descent parser in Java.
It's a lot. It's a mouthful.
I don't think Java likes recursive.
Trying to build a syntax tree.
Imagine. Well, I think I've taken a good approach for this. Because basically I've split every line into one token. So like there's like I have a context-free grammar ready. It's like a program can be segment or element or includer, relocate, or nothing. You can loop.
You following any guidance for this? The way.
I just have a local copy of a modified site.
LiveR has a video on parsers.
I just use some LL1 parser generator to make the tables with. And then I just read the tables and make the functions from that.
Ali!
EVV.
We were just talking about you and how we're not sure whether you and Kappa swapped places in reality, and we're just in an alternate universe.
You are an alternate.
Some of the same mannerisms and speech, rubbing off on one another in a totally sexual way.
I could totally imagine someone shipping Ali and Capo.
What's up, Ellie?
Have you been, buddy?
Not much. I woke up and I was freezing because I left the window open. Because it was raining and I liked the sound of the rain.
I love the sound.
And then I woke up. What is the temperature outside?
Do you have pants on for once, or?
It is 30. No, Ontario, California, not Canada. It's 47 degrees right now. So that is how many
That's so
in
fucking funny.
the rest of the world?
It's so
In
funny.
the 20s, low 20, no, upper teens maybe.
What's funny, Capo?
It's 8 degrees Celsius.
That's not that bad. Like, it's cold,
Like
but it's not.
8.3.
Guess how hot it is where I am.
Not that hot because it's starting to get nighttime.
Yeah, it is. It has
Middle
cooled
of
down.
summer.
It has cooled down a lot, and it's currently 30 degrees Celsius.
Hey, I got it perfect.
Cool down and it's 30 degrees Celsius.
Yes, it gets to 40 degrees Celsius during the day when it's hot.
Fuck.
Sometimes it gets pretty hot where I live because I live in like a fucking bowl made of mountains.
Mm-hmm.
Anyway, I'm gonna stop the stream after this compile.
Cool.
Imagine end of August, summertime. That's what it's like in South Africa right now.
Look at this.
Yeah.
Why is nobody on my share screen?
Okay,
Anyway,
Mark, I'll watch.
So
Southern Hemisphere weirdness.
Seems like a nice temperature.
yeah, that looks very comfortable. Holy shit, I'm jealous.
No way, they actually did it.
They did what?
The company that got trolled on Twitter with the fake thing that said, "Hey, we're capping insulin at $35." They actually did it.
They did the shit.
Holy shit!
They actually ended up doing it.
The reason being is because California is setting up their own state funded insulin production.
Yeah, they're gonna beat them on price eventually. So they got to try to lock in some vertical customers here. Well, that's great.
That literally like could save Matthew hundreds and hundreds of dollars a month. That's awesome.
That is what he needs to survive. But
That's
like
literally
he doesn't pay out of pocket for that. Like he has the ability to pay out of pocket after with that price.
Dude, one vial is currently $100. If you could use like 3-4 a month, this literally is a 10x price reduction. The rest of the world has it this cheap, so like about damn time we do. But holy crap, that's awesome. I know
Dude,
Matt's probably crying.
I haven't spoken to him today, so you know what? Since this news came out, which he's probably still asleep because he was
Yeah.
You guys still playing in the forest?
We've beat it, and
I know you mentioned that the other day, but like you're gonna go back in there and look for more stuff, right?
yeah.
Get on this weekend, maybe.
Yeah, I could see that.
Cool. I got a 3-player going here at my house with my 2 roommates.
Okay, so then it actually upped in speed since I properly connected some stuff. Up to size 1988 minus 99 minus 1712. 177. So it takes 177 logical like ALMs. Okay. And awesome, it did properly. Fuck yeah, it shrunk the registers down all properly. I chose 3 single-bit registers and one 4-bit register on purpose. That way it would properly fit into 2 ALMs, so it properly does. I'm happy with that.
How's the math work on that?
Because each ALM's 4 bits, so it concatenates the 3 down into less than 4, so it just uses 1 ALM for all 4 flip-flops.
Oh, internally those are all using nibbles. I think you mentioned that, yeah.
Yeah. Internally this
you know why? Why nibble is the native?
It's just after a bunch of testing and stuff like that, they resolved to that nibbles offer you really clean and like optimal stuff. There's some companies that use 6 wide rather than 4 wide. It's just how they decided that making adders and lookup tables of that size is the best.
Yeah, there's probably a lot of research behind that.
Yep. Oh wow. Whoa. Make 8 dirty is not even used. Oh. Oh, that's why.
Oh, wired it up with a typo, right?
Yeah, I just forgot to put A in that.
Oh, and also 111.
No, that's proper. Mark dirty.
Oh, my mistake.
I'm leaving that different.
I see. You derive the wire there. I got you.
Yeah. Yep, this is effectively just decoders and like some flags coming in for addresses. That's all this entire circuit is. See, I was going to have in the block diagram, I was just going to have one of these units, one of these register states. But if I have it in here, I mean, actually, so yeah, it is effectively I would need 4 multiplexers. Yeah, I'm just gonna do that actually, because I was worried about having too wide of reads, but this only has it has these 3 out, and I can just have some. I can just use multiplexers to index into that in the register file itself when you're reading to say, hey, this is the status of the registers when I'm reading from it. And the Runahead Queue should be able to read from those same exact values. Yeah. Yeah, I like that because even if that does double, so I'm gonna need all of those multiplexers anyway. So yeah, because I was just worried that these would be like be too complicated to do multi-read from, like the logic would be, but with it being this way, I like it. If that's the case, then I don't need either of these to come back into here. The only thing I need from here is there we go. So now the register statuses can just be read from there because they'll be updated with these. The only edge case that I'm worried about is the edge case where, let's say on cycle 5, this becomes valid and it needs to read register 5 or whatever like that, and it's operating on registers 3 and 4. And then at that same time, you're running ahead and you're on like instruction 11, and instruction 11 wants to manipulate those registers, and you're both in here. Well, actually, no, because both of these would be read out as valid instructions on this buffer, and you select post to this buffer, so you're fine. Yeah, never mind. Because I chose to buffer them here instead of pre-decide, they both get issued, but it can stall. I don't need that stalled instruction buffer at all. My mom's calling me. I'll be right back. I am laid back.
Okay.
My dad's irritating my mom so much right now because my dad had just had back surgery, so I'm buying him a recliner. So he
Nice.
doesn't have to have any issues with his back. And he's
Oh,
and he wanted to
I
buy
just
like
realized
what?
gamer chairs are basically recliners for the young.
Exactly. And like I love my reclining ass chair. It's fucking amazing. And I'm like my dad was like, "Oh, I'll get a recliner finally," after trying to convince him for like a month before the surgery just to pick one out so we could get it for him. Or just like agree to us getting him one or getting one at some point. He finally agreed to getting one, and he was gonna go buy like a $200-300 one off Amazon that just had decent reviews and just say, "Okay, that's my recliner." And I was like, "Dad, you just had major back surgery. You need to get something that's gonna be good and supportive for your back and actually works with the fact that like you're an old man now." He's not that old, but like with the surgery, his back is the status of a really old man now. So he needs to like be a realistic person and take the plunge and just spend the money on a decent one. And I told him I would pay for it, and he's like, "Oh, I don't want to do this. I'll pay for it. I'll put my payments on the credit card." I'm like, "Dad, stop it." And we're trying to get him to like stop freaking out about the fact that I'm just gonna pay for it for him, and he's never had anyone just buy him something like this of like this magnitude before besides my mom. And he's really weirded out about it. And I'm like, "Just fucking stop. You're crippled. Let me help you."
Help you.
He's that stubborn old man who doesn't want to accept no help. He's like, "I don't need it. I feel weird. It's like taking like $1,000 from my kid." I'm like, "I don't care. I'm literally gifting it to you. I'm buying it for you. Just take it, old
Recliner for
man."
1K?
It's funny as shit. He's all like nervous as hell and laughing. And like not laughing. He's just nervous and like I'm like, my mom's like, "Would you calm down?"
Yes.
Oh, dirty flag. Excuse me. Dirty flag doesn't need to go up there anymore because register status is being tracked in the register. That makes me really happy because the stack controller is also going to be weird. The register file itself will probably be back up to 5600 like it was in the last system, but it was 5600 because of poor design last time. This time will be 5600 with a lot of flexibility. So I'm guessing the whole CPU will be probably about the same, about 1,000. My goal is to get the whole CPU in about 1,000 ALMs, maybe 1,200 at the most for the core CPU.
Mm-hmm.
Replace all white space with just a space.
A lot of this is going to be a lot simpler, I feel like. So forward detection is kind of cool. It's mainly used so if like a register is marked as like to be written, but it knows that like that register is being written like in one cycle, it can just say, "Hey, no, you're not to be written. I can mark you clean after all and let you get cleaned here." So it'll just pre-clean, quote unquote, the register so it doesn't shoot it to run ahead prematurely.
Can I use switches with strings?
Do what?
Use switches with strings.
You should be able to. I'm pretty sure you can.
Because one of the first things I learned about Java is don't use equal on anything but primitives, and strings are not primitives, they're objects. But sometimes it works because strings, they're a bit funky. They say that they are immutable. So like you just have one big table of strings, dynamic table of
string
strings,
interning.
and then strings are just the address to that. But it doesn't it doesn't work in all
turning
cases.
is,
They call equal. You could use dot equals, which I don't think is what a switch does.
I assume that a switch would work. Maybe. God, why the fuck can't languages just have like proper pattern matching?
Like
Closure and Kotlin and Rust and Haskell and
I
ML
don't know what
and...
that is.
Pattern matching. It's kind of like switch statements, but it allows you to like drill down into the structure. You like decompose the structure.
Oh, is it like case Z in Verilog?
No, it's like pattern matching.
Case Z, like this, like you're saying.
It is
this
pattern.
bit
It's
one.
exactly the same thing.
Case like this bit is one, and I don't care about all the others.
But yeah, it's generic pattern matching. You can do 1 zeros and I don't care.
You can do that with pattern matching, but pattern matching's more powerful than that.
Well, it's for generic strings. Case Z is just for binary strings. Right. So, what does every token start with? What are all my tokens? I forgot. We have segment start. Segment start starts with an S. And it is not an end. Switch. Line.
Oh, yeah. Okay.
0.
Fuck yeah. So I just realized that there's going to be one major slowdown with this pipeline is that since the head of this Runahead queue is since the head of this Runahead queue is like the biggest issue right now. There's like, well, if you have an instruction ready to go on the outside of this and like the system's stalled waiting for the Runahead queue to empty, because like there's some like major instruction at the back tail of this that's causing the system to stall. If in the current instruction, this will come out and it'll go, cool, this instruction is ready. And since once the instruction gets accepted here, the next instruction cannot be valid if it relies on that prior instruction. The forwarding effectively doesn't work. You have to wait for it to go through. You have to propagate for 1 cycle and then 2 cycles and then a 3rd cycle back into here, and then you can issue on the 4th cycle. So every instruction effectively takes 4 cycles instead of 1 when a forward should be able to take care of that circumstance. So what I'm going to do is whenever you do something, whenever you do a run ahead, there's going to be so you'll do like a run ahead forward detection. So you'll keep track of the last operands, not only of the last things that come through, but also you'll just essentially look through the forwards and send a forward vector that says, hey, whether or not forward A or B, whether or not you enable the first stage or second stage forward for A or B. And when you store that instruction in here, if it then is stalled on a to be written A or to be written B, and the forward bit is set on either one of these for it, it knows that it can be issued. Because it knows that that if the instruction ahead of it is being issued, by inherently being at the head of the queue, it knows the instruction before it is either finished or going to be finished by the time it gets to the end of it. So I can really just condense this down to a forward A. Hold on, I'll do. Sweet. But yeah, I'm just gonna, because instead of taking the 4 cycles for this, the system can go, oh, you are waiting on this operand to write back, but if you would have operated in order normally, you would have been forwarded to. So we're gonna assume you're fucking golden. And since it has to go through the same forward check again, but on the way through, if it is going to, if there was like a 4 instructions in a row that were dependent on each other inside the run ahead queue, it would be able to go A, B, C, D, E, and like go through all 4 of those really quick, or 4 or 5 of those, as soon as, like, as fast as possible, just because it would see that, oh, this would have been forwarded, this would be forwarded, this would be forwarded, this would be forwarded. Which means this needs to be 17. La 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 la. I'm trying to make my, like, my variables names like as direct as possible recently. Like A would have been forwarded. What's that? Well, that line's on when, if A would have been forwarded. A would have forwarded, B would have forwarded. Yeah, let's go. And this means I can overwrite the register status. I don't need that anymore. I just need
Ooh, I have an idea. I could use these content
I
field
like
in
this.
in the token to indicate an error when it is an invalid.
Yes. Yes. This is going really smooth. The stack transaction thing is going to be a little sketch. But as far as the rest of these things, I'm pretty happy with them.
Is it not coloring the module because you don't have an enter at the end of the file?
What?
Is it not coloring the module because you don't have a new line at the end of the file?
Coloring this?
The module keyword.
Yeah, oh. It's just a gray.
Oh. It seems the same color as the other names.
Yeah, it's really close. For me, I can tell though. Yeah, the stack transaction history is something that needs to be worked through, but as far as every other register works well now, which means I'm going to call it now because that means I'm pretty happy with all of this. I just need to write some logic that compares these vectors and shit against the head, and that should be pretty easy. But yeah. This should be fun. Anyways, yeah, thank you for the like 2 people that even came by the stream that aren't here anymore.